Before we get started, I really appreciate everybody. I really appreciate everybody coming out. It's like not everybody is, in New York City, and it's very nice. This big obstacle like Chelsea Palmer together, and we're completely generator. And I think we're going to do kind of like set the tone for today. We're just going to have a workshop where we're just really kind of free form. I mean, we have a schedule, but like we've already coming out of the water. So the goal is to work on each of you to make some decisions while everybody's in the room. Just closer to Interop, right? How we're gonna what our kind of thoughts are and how we get to Interop, from the perspective of business, right? So Antoine's gonna go first. He's gonna kind of do the workshop. Felix is supposed to be here. He's downstairs. Yeah. So we're gonna up his network.
Hi everyone. So what's consensus a couple weeks ago on working from home, we got to talk a little bit about that. And so let's keep it out. Just to give you an idea of where Mark is been working for these two clients, and so there's a variety of topics. I think the idea would be to just introduce you to some of those elements, and then we can work on one version of that. And ideally, the smart build is actually full-time, not me. So if you want to have some better views, better research, and to work that code, you should have. So, not so many words. So, an easy way to start a discussion is talk a little bit about discovery. So, we don't really have a discussion about discovery yet for these two. Today will give you time to start talking about that, discovery V5, and also talking about what we would like to implement in the scope of discovery V5. It's pretty large, and we don't need to do that all the way. Does that make sense for everyone? Anybody else talk about discovery V3? Any questions for discovery at all? Like to know about that later? Yeah. Cool.
Like generically, or like Discovery V5 specifically?
Discovery, yeah, so I think it's going to probably be built Discovery V5 for civil working, because I see quite a bit about that. The reason for Discovery V5 it's a new take on the existing Discovery V5. I don't know if you're familiar with that. So Discovery V4 is just sending your email, which is your address, key, or the recently Philippines team added PNRs, Ethereum records, which allow you to do free form metadata. So now you can add a lot more metadata to your remote identifier up to 3 gigabytes. So you get a lot more out of it. That's been added to Discovery V4 already. So there's a way now for you to create Discovery V4 so you can have these full-on logs. That's better as well V1. And in Discovery V5, we'll be using 16, so it's possible for you to share a lot of information about this here. You can share which jargon we own, you can share your aggregator, you can use it for scheme encryption instead of SSC. V1, you can use different type of encryption rules. So all those options are on the table, but the minimum level scope would be discovery is the existing V4 scheme, which is just assign the data with a 6K1 key, and then you just send that over to this one. Questions about that, you can do that as well.
Yeah, one of the original things that it was put out was so that you could advertise things about yourself, like light notes and things like that. But we needed to advertise shows.
Right. So again, we're not going to go for the whole scope of it, but I think just do an MVP level implementation of that, and will allow us to do discovery, and then we'll some interaction with the clients, so you can have a better way to interpret key points.
Sorry, could you speak louder?
I tried, but I spoke too much. I'll try, but my French accent will be even stronger, so.
I'll figure out how to like make this microphone thingy work.
That'd be awesome. Thanks. Sorry about that. So.
So discovery, would you have another topic after that?
Hey. You gotta stand like here.
All right. Okay. So, do you have a question for Discovery?
Oh yeah, I was just gonna say, so you're gonna talk about discovery, are we gonna like, from there, like branch into other topics, like are you?
Yeah, so we're gonna go by stack, so we start with Discovery and then go down to stack about what's possible, what's being tried, what the state of different lines, different levels. So Discovery is kind of this, non-conflicting topic, waiting for police to come back, so you can actually inject the opinions into the discussion, but yes, that's what I'm going for.
Okay.
So if, if we're going
I don't think it's in.
Discovery, so we have had a wire protocol, phase 0.
Just kidding.
Say a couple of lines of Jen and Denise, just to make sure the
Okay. All right. Okay. So we have had for about a month, Matt provided a phase 0 RCP spec. So right now, as far as I know, we don't really have an implementation of those basic RPC methods been done so far. We've tried different things, but most clients have done something ad hoc to themselves. So a second topic of interest today as part of this workshop would be to have just a discussion between ourselves of seeing what's the delta for each client to adopt that RPC specification. So I don't know who wants to talk a little bit about that. If you're interested, just raise your hand right now. I'll come find you. We can have a chat about that. Yes, 1, 2. Okay. That's great. I guess. So that's what I have for that. So I wanted to also give kind of a circular view of what I know about the different clients in terms of what they have adopted in terms of networking technology. So right now we have a disparate stack between the different clients. We have some clients like studies who started with RPX that works for them. They're pretty happy. They'll eventually want to move to DP2P. We have folks that started with DP2P from the get-go, such as Prism and Lighthouse, right? In Java, we had a little bit of trouble around the road where DP2P support was lacking. So we went kind of for the simple way of doing a simple protocol with something called Hobbits that I can talk about some more. And I think Star, you guys are just getting started. You have DP2P just now, right? So we don't have at this point in time interoperability between clients, which is what it is at this time. It's okay. So we need to talk about how to go about that as we go along. We don't have to have a lengthy discussion about it, just to understand what the delta is would be cool as part of that workshop, is to just get together, put on paper what's missing from the different clients, so we can honestly report and see what we can do. So that would be a separate discussion group for that. Then I also wanted to have the possibility to get Voivod to kind of come and talk to us a little bit about what they've done for sub-testing and if testing. You ready to talk about it? Yeah. Good. Can I put you up right now? No. No. All right. Well, we're gonna wait 5 minutes.
Oh, you can clap for that? You should clap, no, no.
Got him.
Yeah, so we've been working on testing libp2p, pretty much just to measure strictly the protocol, like message passing within the network. So what we did was we built out a client. Daniel, you come up here if I have to be up here. Just kidding. Daniel is with me. He's on my team. But so we wrote out a client that strictly passes messages according to the rules defined by the pub/sub router. And we're pretty much just trying to measure how long it takes for a message to propagate from one end of the network to another. So we constructed the topology in a way that it overlaps. So certain into clusters. So certain nodes exist within each cluster. Some nodes exist within both. So that's how messages are going to be passed, because there could be timing restraints and constrictions within the system. So we just need to make sure that it's optimal. So initially we were just testing gossip sub, but then we were kind of talking about it, and it doesn't make sense to just test one protocol because people won't have any data to compare that to, so it's not really going to make any sense. So we're comparing several of them. And we open sourced our client that we wrote, and there's some initial data available in the repo, and anybody can feel free to contribute. And I would hope that all of you guys would help us in vetting this, because we're not, experts. Daniel, Can I ask a question real quick? Sure. The way you implemented it, did you base it off of the libp2p daemon?
Yeah, so we did it. So what we did was we created a daemon client pair.
Yeah.
So the client is just communicating with the daemon, which acts as a proxy on its behalf. That's probably not the most effective way to do it. Ideally, we should probably just import the library directly rather than building a daemon as well. But I was talking to the Protocol Labs guys, and they said just do that. So they've been collaborative, we're working together with them.
What was the best case for your message passing speed, like from end to end of the network? Like, what's the fastest that it could be?
We don't have enough data to make a conclusive hypothesis. So, I mean, we just have been working on defining the methodology and writing out the client. And do you want to talk about that, David? The methodology. Yeah, I mean, you've been working.
The results look good. But we can't promise that it'll account for realistic network conditions. Those are the things that we need to go into further testing about. But I think we can see why it's an option, because even though it's really just a pain in the ass to build out, it functions. And yeah, we still have to do a lot more testing to actually figure out if it's viable for our needs for E 2.0. But as of right now, like doing preliminary testing, there are cases where we can say that it might not be a viable option, but then there are, but it does look promising, because numbers are, it fluctuates from good to decent. But
So what kind of
well, I should note though that everybody here should be vetting our code.
Yeah.
And checking out that data and making sure that it's done right, because we should all hold each other accountable. So
Have you published results? Or?
yeah, they're in the repo, but I don't think that, I wouldn't consider them, like, I would.
we took down those results to put in our final results, but those final results are kind of huge, and they won't fit in the public results. Yeah, so we're going to be able to see it on GCP, and then you can pull it from there.
And some of the initial results that look more on the decent range rather than good, is that due to increased number of nodes in the network or certain types of columns?
Well, we leave the number of nodes as a constant. We build a network with 100 nodes. And then we have each node paired with a minimum of 10 nodes. And that's how the message is.
So it's like topologies.
Right.
Yeah, so.
Oh, wait.
Yeah, so the topology here, like that's just a simpler,
I just want to point out, so
Is
this
this
is
just me, or
this
am I
thing's
so
free, you know? Free, and,
Sweet, dude, it's super. Very Berlin. So like, these green bad boys here are inter-cluster nodes, and the red ones are cluster specific. So, but we've changed the logic in our algorithm as to how these peers, well, okay, first of all, they're statically paired. But we changed the method in which we pair these nodes with one another. So that way it's more full match. I guess, anything else? We good?
So these just flood sub as well, right?
Yeah, but it's a flood sub, gossip sub, and then we're gonna test the plum tree implementation and Artemis.
That's,
So, but we're not complete with all of those. So we've been focusing primarily on like nailing down the methodology, identifying the topology, writing the client and making sure that everything works properly. And then just like, you know, trying to get other people to just check the code and verify that everything works. And so it works so far. We're probably going to test it more, like, we'll probably test it at a higher scale as we go along. So if you want to scroll down, because I can't walk over there. Yeah. So the test procedure, we like build the network, provision the nodes, configure the network conditions according to the test case. So some of this is copy pasted from our work last year with youth research when we started on like the sharding P2P research. But I rewrote a lot of it. So we have like a message struct. So when a node receives or generates a message, it writes to a log the timestamp, the message was received, the message type, which we actually don't use. Do we use that? So?
Message type, yes.
Okay.
Yeah, send or receive.
And then message origin, like the node that sent the message, the message destination, the last relay node, and that's so we can like measure hops within the network, like how many hops does it take to get to its specified destination. Then we have the nonce, that's like a counter essentially for each individual node, so we know how many messages it was sent within the network. And that allows us to kind of measure if any messages are dropped or not received, or you know something is going wrong there.
No, we don't have that.
And then we have the message size, so we're going to be testing at different sizes. And that was something else we wanted to get feedback on. It's like, what is the average payload within the network for each two? So I think like our initial tests, I mean, we have all this defined lower as well. So within each series, we generate a control group. Then within each series, we observe one particular metric and see what effect that has on performance. And you can see. The idea is to like iteratively go through everything, establish like a data set, and then based on that data set, we can kind of say, hey, this is good, or this is bad, or this is what we can change, and this is why it's like bad. I mean, so just to be clear, like nothing is probably going to be good right now, but that's fine. Like we just need to figure out how to build it better, and I think we have to like do that together, do that iterative process.
Your control group, what's the series 1 and series 2?
So like in series 1, everything is the same. We're just trying to establish a baseline for performance. Within series 2, we're changing the message size. So 500 bytes, 500 kilobytes, and like 1 meg. So
okay.
Where is the actual?
What's that?
Like, I mean, this is just a network parameters, right?
Yeah.
Yeah. Okay.
And now we're testing the network.
Sure. Yeah. But there are no like results in this table.
No. So I'm not here to share the results with you guys. I'm just here to tell you about what the methodology that we've established and the client and what our logic is. And that's up to you guys to like kind of help us.
I'll send you information on payload and also frequency.
Yeah, because said it once, say it a million times. I'm a tool.
So let me be a useful one at least. All right, so yeah, I mean, the tests that we've run have really just been to verify that our system was correctly implemented and that the client works. So I think that we should all work on this together. Everything's open source, so you know.
You say you don't have any results. You don't have any like.
We have results.
Anecdotal kind of.
We don't have. I don't want to talk about anecdotal results. I want to present conclusive data that's objective.
I was just curious if like you compare that with like other clients that are using the if that.
So
Yeah, that's something that we can do.
I don't know if President, you got any feedback from your business? Yeah, so on our testnet, which is, this was rolled out to the whole thing, but at least the ones that we run, our 99 percentile is under 2 seconds for a message copy. So, but that's like co-located style, which is still like not good because they're sitting right next to each other. So
Right, yeah, so it's.
we also don't have very conclusive data. We're starting to collect it. Maybe in a week or so, we can have a better idea. But I would say that 98% files under.
Cool. Well, that should, in my opinion, I feel like that would be kind of high, right? I mean, yeah, especially if there's no latency or anything else added in between. So then we need to identify, is it like the protocol that's screwing up, that's like taking too long, or is it our implementation? Like whose shitty code do you blame? Like mine or yours? Like, you know what I mean? So the way that we can come to those conclusions is just step by step, iteratively, come out with data, let the data speak. Like we all have opinions, but you know what they say.
Let's say it.
Oh man. For our next company. All right. Yeah, so whenever we break into sessions, it'd be cool to kind of just talk about it and go over it together, you know, in a more one-on-one way. That's not as awkward as me standing up here looking at Antoine. Look at this majestic beast.
So what's the idea of the session? Like some of us talk about this, some of us talk about
Yeah,
this.
like we did last night. Yeah, we should break into like little groups and talk about what we want to talk about. I'm particularly interested in hanging out with this guy.
What?
What's up? Where you at? Yeah, I think we should just break into topics and kind of, you know, reconvene. Like I wish there were a whiteboard here. Because it'd be nice to have an early whiteboard session. Oh, paper. Is that like tape? Yeah.
Yes, we have to.
The paper.
Paper and tape. I like to go one last thing.
Here you go. Let's see.
So, thank you. All right, so there was a question from Danny about 2 weeks ago. I started working for Moloch, and part of the work for Moloch is to do an if2 tester, which is very generic and doesn't mean too much by itself. So just to put that into this network discussion, it doesn't actually test any networking feature at this point, because that's not really the point. But we want to make sure that if you have several clients of your implementation, not even across implementations yet, that we can objectively test that you're able to have all your blocks being populated on time. So right now, the test, the scope of it is to just be able to have some output from each of the clients over time in some sort of a JSON format. And that format is just then being compared to make sure that we were able to come to consensus for each block or for each block. So I will need help and feedback from you guys as I go along. Right now, I've been working with Prism Lighthouse and of course Artemis. This stuff is actually just the runner itself. It's not actually the runtime. So the runtime is actually being provided to us through Whitebox, and thank you guys for that. It's awesome. Through a runner called Genesis, which is leveraging Docker, giving access to the nodes, organizing that in a nice way, making sure that the containers are fine. So I have a Jenkins instance that's up. I put up last night late, a video on Twitter that you can check out where I actually show that in action. The idea is to use that across all lines over time, and then every time you have a new build, just rebuild that, turn that into this automated framework, and just make sure that we're all up to speed, and so we can have some sort of a matrix of compatibility to versions of things. You okay?
So you're throwing lots of clients and make sure they're the same outputs.
Just one client of the type at this time. So for example, a 3 Prism node, 3 Artemis node, right? And they all just run like that, and then we make sure that you get the output. Now, the idea also, as we do this, is start standardize this logging practice so that we can start having a way to mix the clients all the time.
So if you take 3 Prism nodes and you're throwing the same thing at them and hoping that they come to the same.
Yeah, that's right.
Okay, but they're running the same software and they're getting the same inputs.
Yeah, that's enough.
What are those inputs? Are you using?
That's the thing you get, and they just have like the events initially, so they just start like generating for your ever stuff, something like that.
So you start from Genesis basically.
Yeah, we start from Genesis. Yeah, we don't have initial state like that, but we should start incrementing the difficulty of those tests as we go along, so that we can start testing more interesting situations. But I don't like what would be cool is that you have like 3 nodes at a certain level, and then you add a 4th one, and you watch as it syncs back and is able to keep up with the other one, right, for example. So we'll be adding more things like that, but the idea was to give the framework that the client implementer start having a way to be able to test that. How useful that is depends completely on how much you want to use.
So this is independent of the YAML test vectors, the static tests?
Yeah.
Or
so that is actually something we can leverage. So we can actually have those YAML tests start running against those clients as we do that. So we can have safety checks against the various like methods, behaviors of clients. Any questions about that? Okay. Well, repo's open. Root patches, opinions, suggestions, comments, trash. I'm here for you. Okay. All right. This is very dangerous. Where's the man?
So it sounds like you just want to break into.
Yeah, that's what I'd like to do now. Yeah. So if you want to talk about discovery, I think tonight we can talk to you about this DeFi. If you want to talk about what needs to be minimally implemented, we can talk about that now. We can have another group around white block. If you want to talk about testing methods, the payload size, something like that, that is the right thing. Does that sound good?
Should I present it or like, I don't
Should
really
I
know what
talk
the
about it?
agenda is like.
Yeah,
This
Most
session,
should know this.
okay, so this session is like a fairly long session. So there is an option that like we can just do sequentially. You know what I mean? Like talk
Sure.
Discovery V5, like run with it, then move on. So that's
Yeah, exactly.
Who wants to hear from Felix on Discovery V5 right now?
Yeah, I can.
All right, come over.
Yeah. So, the table is really short.
Yeah, it's
Or you just,
awkward.
or you just plug it directly into the speaker.
you can move it.
Oh, I see. Well, yeah, yeah, I don't really know, what you guys are interested in. I mean, so, we had some discussion last night a bit about that. It looks like maybe some people got confused. So who here has actually like seen the Disney 5 specs? Or, okay, a couple people. So, maybe you should just pull them up like there, but,
Where is it located?
yeah, yeah.
What's that?
Oh, yes.
Oh, yeah, for this, thanks, this is actually very cool.
Which one do you want to?
Yeah, it's the main one. Yeah. Okay. But it's always cool. Okay, I can just keep talking. So the spec is like, it's the spec is like pretty close to being done. The basic, like I guess, like if you haven't read it yet, I think the part that's like that would be like most interesting to you is probably like this part, like the actual wire protocol, and then this is also maybe like the least intimidating part because it's literally just like the bytes on the wire type of thing, and it doesn't really go into like the most complicated part is this part, which is this like handshake thing, where you actually like do like some crypto stuff to come up with the secrets for talking to some nodes. So this is a bit like implementing this part is like kind of an independent sort of exercise. Like if you wanted to actually implement this protocol, the best way to start is just implement this part because it's like reasonably standalone. And then in general, I think further out, if you have if you have the handshake going and the actual packet encoding going, then like basically the next step would be to just make like would be to just implement like academia parts of it, which should be reasonably straightforward because there are implementations of the predecessor of this protocol in pretty much every language out there. So you can just like take and like a V4 implementation and like put the new wire protocol on top, and then you already have like 70% of this protocol going. And then like the final part, which is like if you go all the way down, there are a couple of messages in the protocol that like basically starts here. These are about like the ticket, and then further down there's the topic query. So these things are maybe not as important right now because like implementing those, it means like there's additional theory behind those, and like there are additional data structures behind those, and getting those right takes maybe a bit more time. So this isn't something you have to necessarily implement as a first step. So these are kind of optional at the moment because, well, yeah, I mean, this functionality is really nice, but you don't really need it to like get started with the protocol. It's more like it's like the second half of the protocol that you can actually get to later. But now that I'm talking about it, I kind of realize like who actually knows like what this V5 is, like of you, or who doesn't know.
Antoine gave us a little briefer this morning.
Okay, all right, yeah. So maybe just in general, like why should you even implement this protocol? So this is like a way to find other participants in like a P2P network. So it's like it's a GHG that you can join to find like everyone else. And we're using the predecessor of this protocol for ETH1. We've been using it since the beginning. It's kind of it's working okay. But so the effort. Like this isn't something like we didn't make the V5 specifically for ETH2. At least not really. Like the V5 effort has been going on for at least 2 years, and we made it mostly because it solves some of the weaknesses in V4. Like there are some design flaws in the V4 protocol, and we created V5 like to address those. But then meanwhile like ETH2 got started, and looks like this is actually a pretty good fit for ETH2 as well. So I feel. By now we can basically say that like, we're designing this like for ETH2 because we're definitely looking toward like using it for ETH1 also, but obviously we run the same problem. Like everyone has to implement it, right? And ETH1 implementers are in the exact same spot as you guys. That maybe there's some overlap in the group here, where some people work on ETH1 clients or have worked on ETH1 clients in the past, and it's just like. Fixing the networking is, generally something that not a lot of people are interested in or have the capacity for something. So that's why, for me, it's just been like an ongoing fight to, push people to actually like move their networking forward. And so I think like implementing this protocol is going to help with like both ETH1 and ETH2 in the long term. So I think it's like a universal. It's just a good thing. Yeah.
What's the primary differentiator between ETH2 and ETH5?
Right, so that one is, that's given on the overview page, so if you just go back one page and just go to the bottom, you can see that here. So there's, so the main difference is that like we have this like topic advertising system now, which allows you like, you know, register your node under a certain topic, so people can actually find you under that topic. You can relay arbitrary node metadata, so in the V4 you can only relay like IP addresses and ports, which is it's yeah. Okay. It's like the basic functionality of V4 is just to relay like IPs and ports, and the V5 you can relay like arbitrary key pairs attached to any node. So that's the big difference. And then the other points there, these are just basically like protocol bug fixes. So you know, it's the protocol supports multiple node identity systems at the same time. So for example, there can be nodes that are using a SecP25631 key as their like primary identity key, like we've been using for ETH1. But you can also use like an ET25519 key, for example, if you're using the key, you already have a key like that because that's probably what you're going to use for node identity. So you can just use the same key for your node identity in the DHT also. And then nodes using like two different crypto systems for their identity can actually communicate, so they can all be in the same DHT. Like that's this point. Right. So before we have this big issue with the clock, where like you have to be like in sync with NTP or something to actually like use the DHT. So this is removed now. There's no clock dependency anymore. And then finally, the whole thing is like encrypted. Like it's just like V4 isn't encrypted. So that's.
You brought up one when you talked on one was that having the same DHT between ETH1 and ETH2 to make the DHT overall stronger.
Right. Yeah. So this is like a big goal. So the big goal is because of the topic system, it's actually totally okay to like co-host many different applications in the same DHT, and that just benefits the system, like the security overall. Because if you have with DHTs, it's just, if you have more nodes in them, it becomes more resilient against attacks. It's just harder to take over the system. So if we're going to be using it for ETH1 and ETH2 at the same time, that's going to work. If you implement the topic system correctly, it's basically going to mean that you get all those ETH1 nodes or all those swarm nodes or whatever. They're all going to be in the same system, and it means that there's just more. There's just like more people you have to take over to mess with the structure of the system. What was your question?
Would it be really floating to hold all that data? Like people want to do
What do you mean?
Would it not need to limit have to maintain all that?
It would not affect performance.
It doesn't affect performance. I mean, the system is it's a scalable index. So in that, there's this is explained way up. So if you go up now, you can kind of see there's a high level, this section is more like a high level. You can kind of see that basically, the idea with the system is that, you can use the DHT for any purpose at no cost other than actually running the protocol and storing a limited number of anonymous records. And that limited number doesn't increase, with more usage of the DHT. So there's a fixed amount of info that you have to store locally, regardless of the size of the network. But the more nodes join it, the more capacity is there. But the capacity of the system is really large actually. So there's we haven't. And then as more nodes join, the capacity increases. So there's. Yeah?
If I'm the first node in the network, how do I become aware of each node?
Right. So if you're the only one, then you don't need discovery, right?
Sure.
So,
if I have a friend? I have a friend that wants to.
Right. So the system, the system doesn't really work with really tiny networks. So it doesn't this thing is fundamentally useless if you're making a tiny network.
Yes. So what's the minimum on the nodes I can securely participate without any compromise?
I don't know, 1,000 maybe? So you need because in the end, it's if you have such a small network, this is built for like internet type of use. So if you're making like a private, like some people run discovery on their ETH1 private chain, but this is just silly because like there's no security there, and technically you don't need it. You only really need this if you're actually trying to peer with like random people from the internet, because that's what this does. But you need like quite a lot of people to make it like really good. Like if you think about it, like the BitTorrent mainline DHT is like maybe a couple million members by now or something, and that's like a really good size because at that point it just becomes. We could, you can publish like the other component to this that you have to implement if you make an implementation of this V5 is you have to implement the node records. But with these node records, you can store them anywhere. Like you can just publish them in the BitTorrent DHT if you want to, if you want to do that. You can just pick a node point in BitTorrent DHT address space and just publish node records there, and then like load them off there, like to Bootstrap. But right, but the problem is you actually need to join the BitTorrent DHT for that. So it's just you're incurring like additional traffic cost, just for for that purpose. You can do it. Like if you're into that, you can like bootstrap off of. You can publish node records to IPFS if you want to. Like there's nothing like there's no problem there, right? It's just
You have to be just deep on DNS, right?
Or on the DNS, like there's a million ways to bootstrap this, but like like the goal of the bootstrapping would like be in the end to like join this DHT though. Like if you have to join like 2 other DHTs just to get to this one, it's kind of weird. Right? Cool. Like any further questions or like yeah?
Yeah. So implementing this within the context of the original plan is to use the P2P. Do you see this as being compatible? Like could we use Discovery V5 and still use P2P or the P2P for the rest of the?
Yeah, sure. I mean, it doesn't. So this is like we had some discussions with I think people from the Lighthouse team. I don't think they're here though because they're from Australia. So they are like we had those questions come up because they actually started implementing this, and they were like, okay, so how do we fit this in with the whole libp? And then like if you're a bit familiar with like the libp architecture, the way to fit this in is to it's a bit like the libp like MDNS or something. It's like the MDNS is kind of like the MDNS component of libp is something that it implements some protocol underneath, and then it gives you like the discovery API like on top of that. And you can do that with the DISC-V5. If you implement DISC-V5 and put the like libp discovery interface on top, that's totally possible. But we checked it out like a bit last night because we were actually trying to see like how hard would that be with the Go interfaces and everything. So probably what you have to implement is something like you need like a key book and an adder book or something that's based off this. Like that's kind of how libp does things. So it has this abstraction called the adder book, which is like some abstract store that can give you the multi-adder for a node ID or for a peer ID. So you can implement that with this if you want, but you kind of have to see that like underneath this abstraction is just going to be like this protocol, and it's a totally standalone UDP-based protocol. There's no you can't compose it out of libp components. You would actually have to implement the protocol and then put like the libp compatible API on top to pull like your multi-adders out or something.
Do y'all have any plans of like producing like a proof of concept of that?
Yeah, sure. So I mean, for me, it's like I'm working on the Go implementation in Go Ethereum of this. It's like maybe like halfway done. Right now, I'm a bit behind because I wrote it like concurrently with with the spec. So right now, it's a bit behind on the actual crypto. Like the crypto in my implementation is like from an earlier version of the spec. So I'm still kind of updating it. And yeah. I don't really know what to say now. So you can't like I don't think there's like any inherent problem with like using libp alongside this because it doesn't tell you like what your transport protocol should look like. Like it doesn't do that part for you. It only gives you like it's a thing that you can pull like multi-address out of to connect to using whatever other transport, and then that transport can be libp or like anything really. And then so it's not there's no like inherent issue with libp or something like they're not conflicting in any way or something.
Like the arbitrary metadata storage is about places you can advertise or libp together if you were wanting people to reach you via libp.
Yeah, so the arbitrary metadata, this is like, yeah, it's really arbitrary metadata. So for ETH1, we have we're still working on an actual, like the usual metadata that you want to publish in a system like this is, like your IP, your port that you can be reached on, any like static key material, like a public key or something. So this is just a bare minimum to even connect. But then beyond that, we're working on a proposal for something like like in ETH1, we have this like static concept of a network ID, which is just a single number that identifies the blockchain that you're on. But over time, we've kind of seen that this isn't really enough because every time people fork off or something, you can still not like the network ID doesn't change. So it doesn't really identify the chain in a good way. So we're working on a proposal to actually create something like a dynamic network ID that like changes over time as you advance in the like fork hierarchy. And then basically that, we're trying to make that something like a 16-bit identifier that contains all the info you need to really distinguish like what chain is this, and then this kind of value, like this 16-bit number, that would be something that you probably also put in your node record just to tell others like what you're up to. And then you could, like, if you find a record like that, you could know, okay, so at the time when the node published this record, it was, up to block 1 million or something, and it had this fork configuration. You could kind of read that out of this. So this is like the kind of node metadata that you can relay as well. And then like for ETH2, obviously there's some metadata, like, like which, if you're just participating in a shard or something, you could put like the shard ID in there, or, like if you, just in general, I mean, maybe we're not thinking about like concurrent ETH2 networks yet, but if there are many different concurrent ETH2 networks, like multiple beacon chains or something, then you also want to identify those. And just, like, that's the kind of metadata that you're looking for. There is a limit though, like the node records are limited in size, so they can be up to 300 bytes in size. Like we made it like a hard limit, and we're at 120 bytes right now just for like the basic info. So you have like maybe about 180 bytes left for your info. And I think it's good to have some limit there, because it also means that you kind of have to think really hard about what to put there. Like you can't just put, like picture of a cat in your node record. It's not useful. Like, you have to use this space really wisely to really. Cool.
Use a standard to just have the shard around a bit field.
Yeah, for example, you can, that would be something, for example. Like having for ETH2, because there's a fixed number of shards, would maybe make sense to make it like a bit field or something, but we'll see later, because I think this is something, and you can change it like at any time. There's no, like, I mean, this is more like, you can come to consensus about what's the right way to like announce shards and stuff, but you can do that like way later when there are shards, and like, this isn't something that you need to necessarily like tie yourself to right now, because cool. Okay.
Yeah, so you mentioned that there's some subset of the protocol that we were discussing on the wire protocol, like how to tackle it.
What do you mean?
There is, like, over time you would build up a full protocol, but what you mean, like the subset of the protocol is what we discussed on the wire protocol, when you're like, do this, and then this, and this, right?
Yeah, there are like, maybe, should I like make that more explicit and like define the subset somewhere as a document? Or just say, implement this and this message? And just have that like as a plan, so you can.
It'd probably be useful because a number of people are probably gonna open this up.
Right, yeah, that makes sense. Yeah, it's kind of, yeah, it's not as, it's not, maybe, yeah, it's not as obvious for people, like, what's actually, like, important. But, I mean, I guess this is actually something you'll see when you implement it. Like, when you implement it, you'll know, because, when you're implementing the message, you need to actually return certain info, and if you're implementing it, you'll see, like, I don't have a source for that info. Like, if someone asks you for like nodes for a certain topic, there's no way you can provide that if you don't have the right data structure to like do the querying, right? So it's kind of obvious when you're actually implementing it, because then you'll just see what kind of info you need at that point to actually participate.
And one more question: as you work on your version and as other people bring versions of the spec, is there any sort of like testing or performance analysis that you're kind of doing? What does that look like?
Yeah.
What metrics are we concerned about?
So, like on the testing, what we're probably gonna do is we're gonna integrate it with the V4. Like we have a V4 test suite now, and we're basically gonna make a similar one. I'm a bit excited about the work that Whiteblock and other guys are doing about these types of like client testing frameworks, because I think that ours, we're using Hive, and it's kind of a hack really. It's not as nice to use. So I would probably want to create like a standalone sort of test suite that you can then import in the Whiteblock framework or something to do the testing on. But the testing that we're focused on is really like testing the communication between two nodes, and not so much like doing network testing at large. Because it's kind of hard to actually do that. Like, I mean, we did some theoretical simulations in the past of the system, but yeah, like, I mean, it'd be nice to do this, but you need like a working implementation for it, and then you can just like run it. Like, you can run like 1,000 copies of it and see what it does. That would be really useful, but you can't really do that now because.
From your perspective, are there any unknowns or things you're concerned about as we move to production?
There are some open issues in the, if you go to this one. So this is like a bit like the other document. So this isn't about the wire protocol at all. It just describes, like the back office of the wire protocol, like what's actually like going on inside of the node. And if you go all the way down, you'll see that there is some stuff there. There are some security considerations like here. And so these are security considerations about the topic advertising mechanism. And there are some things there where we like really have to do more testing, like to see how actually it holds up. So we think it's going to hold up pretty well because there are some things there that make certain attacks harder, and it's explained here. But we'll actually have to really like see in practice how easy it is to break, or like these are things that I'm like most concerned about. That actually like some of these things that we thought about that our response. So this is actually not true anymore. So we kind of like I wrote that this is not solved. It's actually so this case would be something like, just to give an example of what this section is like. This would be an attack where, for example, you publish nodes that aren't actually participating in discovery protocol in any way, and if you do that, then all the others in the DHT are going to go to that node and just start sending just start directing traffic there, and that can be like an attack on some totally unrelated system, for example, because this is a system that relates Ultra endpoints that you put in like GitHub's endpoint there, and people are just going to hit GitHub with their traffic. So there is I wrote that at the time, but actually there are some like limits to the system that like prevent that from being like a real problem in practice. So there's like enough like cross validation going on to say that you can't just publish like an arbitrary endpoint. Like the endpoints that you publish actually have to be like verified to be participating in the discovery protocol in order to get registered. But yeah, so these are the kinds of things that we're like a bit worried about. That later like some weird corner case might come up where you can actually like publish something that shouldn't be there, or
Is there a way that, like, I realize this is like still in work, you know, I think it'd be nice, like, obviously to have like the same discovery, you know, methodology for reform. Is there a way like you could implement like a minimal version of this, and proceed with that while the rest of it's finished out? Like,
yeah, sure. Yeah, that's what I meant earlier. So I think now we're at the point where there's like enough context to like say that thing again. So like if you're starting out with implementation, like there are a couple of parts that you need to implement. You need to implement the node records part. This is kind of straightforward. There are some things that are less straightforward that are kind of optional about maintaining the local record. So you can do that like really well, or you can be a bit sloppy about it, or like there's some amount of effort you can put into making your local record really shiny. And then obviously like the next thing, if you want to start talking to protocol, is to implement this like handshake pod. And this is so like this is a basic requirement, otherwise you can't talk, right? And then once you have that, you can go and like implement like the message handlers for the messages that are down there. And then as you implement each message handler, you're kind of going to see like what's needed to really do that. Like if you go slowly, like for example, just to handle like the ping thing, for example, that's like you don't really need all that much for it. You can basically just it's a simple handler where like you get a thing, you send like a response, and that's it. Like you don't need any fancy data structure for that. But then if you go for this, for example, you can kind of see that this queries for nodes at a given logarithmic distance. So you kind of need a way to actually like get the nodes at that distance, and you need a data structure that can supply those. So obviously you need to implement like the cadavia table for that, just for that request. And then there's the response to the find out, and then that's pretty much it. So the minimum implementation will be like basically it's the same message set that we also have in before, like ping, pong, find node, and nodes are the 4 messages that you kind of need to have like a basic sort of DHT going. And then the rest of the messages, these are like for the topic advertisement, and these need like additional work. And it's described in the theory document like what you actually need. Like there's a topic table, there's a radius estimator, like a topic radius estimator, and you need like something like a ticket store, which is basically the thing that like hands out tickets to others, and then you actually have to implement some crypto, like verify the tickets, and like the topics are more complicated.
Yeah, so like we could start off with just like static nodes and start getting testing and everything, but like would there be value in like if we could get a resource to to digest this, pare it down, and then like put it in our in our initial.
Yeah. So can you go back one more time? Okay. So no, just one more time, like to the top. Yeah. This one. Oh, right. Oh, it's using your phone? This is such a hack.
No, man.
Okay, that's it.
Should I click it again or not? I just need to
Yeah, I know, Mike. So, all right. So, these are the whole thing. It provides like 3 basic functions, right? So, you can you can sample the set of like live participants, like all of them. You can just walk the DHT, and to do that, you only need the 4 packets that I mentioned. Like you only need ping, pong, find node, and nodes to perform this function. This is the topics, and then this one, there's some updates coming where I guess we're going to add one more message that like allows like authoritative resolution. And authoritative, like these two features, these are the things that V4 could also do, and this is like obviously the new thing. But before V5 can do them like a bit better because anyway. So, but the authoritative resolution, this isn't like very important in the beginning. It's more like something that is nice at some point, but you don't really need it. So really, like the only thing you really need is this, which is like find everyone else. So, and you can do that with like pretty minimal effort, and then you have the same functionality that you have in the V4, which we're using for E1. So it's like good enough for a lot of things, right? Yeah. Right. Yeah. So this is something that with the Eclipse attacks, it mostly comes down to like making implementation time. We can't give like so there is a bit of a trade-off, with stack versus the actual implementation, and like what are the additional like security measures you can put in the implementation versus what is just something that, because some things you just don't want to specify. Like with the Eclipse attacks, for example, we had a lot of like back and forth also with researchers on the specifically on the Get implementation. We added some stuff there that will basically probably never be in the spec. Like things like we have like per bucket IP limits or per like table-wide IP limits. Things are just handled in a certain way. There's certain things like, okay, if you send a request to a certain node, you actually have to verify that the response is coming back from the exact same IP address and port that you sent the request to, things like that. And this is just something that like you notice like these things it's silly like to put in a specification, because the specification would just like grow a lot if you like spell all these things. But obviously they're very important because they make the implementation actually secure. And then specifically about Eclipse attacks, like the main thing to remember there is that like in order for this to be safe, like you have to kind of ensure that the table can't be overtaken by people just randomly connecting to you. And this can be kind of hard to achieve. So the way we achieved it in Get is to so first of all, we have the IP limits, which means it's like way harder to spin up a lot of nodes to like build a table, because you have to actually like rent a lot of different servers around the world to like get to that point where you have like enough IPs. And then the second thing is that actually the way the table works is like if it's low on nodes, like if the table is like half empty or something, it doesn't actually allow anyone to enter it just by connecting to you. So it will only ever take nodes in that it found through some query that it initiated or something like that. So basically, this kind of, it's like none of these things are like hard guarantees, because in the end, like there's no ultimate solution for Eclipse attacks. There are just things you can do to make it like way harder. So these are this is my best answer. And it's important to remember also that this system, it should never be like the only system that you use. Like there are still like it's a discovery mechanism. It does some good things, but you shouldn't put like an absolute hard dependency on that. You still have your like static peering. You still have other ways of discovering, like querying like node lists on the internet and things like this. Like you should always, like when you're making implementation, you should always check that there are multiple ways in which you can actually find others. Not just if you only rely on this system. There are many ways in which this can break. Like if you're at the airport, probably you can't use it. For example, like it's not always usable, and then it definitely has some security, but it doesn't have like ultimate security. You can never achieve that. So you have to like diversify your strategy there. Cool. Okay.
Where are we going? That's an honor. All right, I see people standing up. Take a 5 minutes bio break. Good time.
It's great.
It's great. Yeah.
Bio break.
Let's take time. Wait at 50.
Yeah. 11:50.
Yeah, 50.
Then I can give this one up.
Yeah. You had it at one of them before.
Okay.
I took a couple out of my bag for some stupid reason.
Here we go. Let's see if we can get this video to be
You still need that one?
what?
You still need that one?
Let's see. Let's see. I'll bring it. I'll bring it back at the end of the day.
All right, y'all. Hey, let's bring that in. Get ready to get started again. Ronald! Let's come in, everybody come in. Let's end the side conversations. Let's start getting going again. Sorry. Okay, I mean, we can sit. Hey! Supposed to say it fast. It's like camp.
Mic check. Hey, hey, hey. Disconnect. So Terrence is leading session about validator design. And he's Brad Labs. It's pretty awesome. And just like before, like we had the Discovery D5, Antoine, Felix, thank you, by the way. Keep it free form. Let's talk about, issues and what we think we need to work on. I think validator design is a pretty important topic for that.
Okay, I need a microphone.
No, you
probably should.
Damn it. All right, I'm gonna move this closer.
Yeah, let's move closer.
It's like check.
You're gonna need to carry that now.
That's perfect.
It's kind of blocking the slides.
Hey guys, thanks for having me. I'm just gonna split this section into two parts. The first part is more about the open discussion on Weekend and validator APIs and protocols. The second part is more about our Snaggle Labs learning experience. What have we done so far, and something we learned and would like to share with you. Something we would like to share with you guys. I would like to hit a little bit open format, so if you have any questions, just shout it out. We don't have to answer everyone, so anyone can jump in. And if you want to answer questions, just go for it. So let's get started. So the discussion first started in Prague, where we had a validator workshop there, and we also had a validator workshop in Sydney as well. And from those two workshops, what people really like from those two workshops is the separations of speech node and validators. We're pushing towards the directions of having two different entities. So a beacon node essentially maintains the state of the beacon chain, and it communicates with other beacon nodes. A validator client maintains the private information. For example, your private keys, your withdrawal keys, your proof key stuff, and you don't want to share this information with other people, otherwise you probably lose money, right? And you also propose validator duties, like propose logs, you send your attestations. So I drew a little diagram right here. So in the perfect world, you see like there's different nodes, lighthouse, roaster, prison, and there's different validators connected to it. So that way you support like interoperability. So does anyone have any questions so far?
Will a validator client likely have like multiple validator stakes associated with it, or will it likely have just a single validator associated?
So the validator client in our design is very lightweight, and I'm not saying our design is right, but our design is very lightweight. It doesn't maintain the state. The only thing it stores is its proposed data and slash data. So one stores information just so you don't get slashed, but it doesn't maintain state. When you need something, you request this information from the beacon node.
So let's say I have 64 keys and I have two public keys.
Yeah, that.
Do you have these two public keys live in one validator client, or do you have two validator clients instantiated with each one?
We can do both. So for our testing, we found it easier just to have one validator client which maintains 64 keys. So we have the flexibility for doing both, and it's up to and at the end of the day, it's up to the user to for what he wants to do.
Seems a route that I would take, just in that, like, although these are separate entities from the protocol perspective, like from a user experience, you're like, I'm running a piece of software that is maintaining my keys and maintaining what I've signed.
Yeah.
And you want to have control of the beacon node, right? Like you want it to be one that you've started, not like as a service, you know?
Right. So right now, this is under the assumption that validator trust the beacon node. So there's a trust, right? Because you have to ask the beacon node what you have proposed, like what's the right information. If the beacon node like you, then you probably respond. So this is assumed as a trust in the beacon node. Okay, so what do we want for this protocol? Right? By protocol, I mean the beacon node and the other protocol. We want something that's maximized interoperability. We want something that's widely understood. We want something that's human readable. Right? We don't care so much about performance because it's a very low bandwidth area. We don't need that high bandwidth to propose for investigation. So what we want is that interoperability, right? So with that, there's a few proposals so far. That's a proposal that's proposed by other teams. So there's gRPC, which Lighthouse and Dismantled Labs are using. There's JSON-RPC and there's RESTful HTTP, right? So we use gRPC right now because it's well-defined API enforcement. You can also support interoperability. For example, we have a gRPC gateway. And but the downsides is it's a non-human readable transport, so that's the downside of that. And there are people who want to use JSON RPC, there are people that want to use REST for HTTP, and they all have their pros and cons. But I guess the discussion so far has been we want to finalize the one protocol that we can support, right? So there has been issues and PRs made by Luke from the IOS team. The issues you can feel free to look at it, and then there's also the message formats being proposed. And Luke did a great job at creating a Swagger page. You can get it as well. So with that said, do you have any questions regarding? And it seems like the general direction is pushing towards the RESTful HTTP right now.
Yeah, again, duties, I think. Probably. Get duties like returns you back, what you need, like on a first off basis, first on a basis. Like you actually need off basis, like every single slot.
For our design, we only pull it during the epoch 1. We only pull it once.
Although a stable chain, well, we can not agree on what to do, but if there were some sort of reorg around that boundary, you could, when it comes to the slot that you thought you were going to be missing to. The reorg would have to be more than a peacock view. So in general, like you relatively know what's happening, but checking before you sign something on slot lists is place. I know you get peacock overhead on these things, but I do believe they're still subject to some reorgs and all of that.
So like the only reason you want to check on first slot basis is to double check, right? It's not actually because it's not actually required.
Right, and the worst thing to do is lose a little bit of money by testing something that you almost better AC because valid, but you're not going to be spot not double checking.
Right.
So
would it make more sense then to like maybe open up with another there that's like exclusively just small? It's kind of like unnecessary to forget all that.
You're saying return one.
Yeah, like return like a boom.
Split out the code there.
Yeah. This seems like overkill. I feel like that would have been enough for you guys to every slide. No, I mean, it's just something we were thinking about is having an administrator to notify the client. It's going to be, it should just kind of about it is we're supposed to do the minimum amount of work, so we really didn't ask for the expectations to change. Right. So for one thing, you could, and then it adds more complexity to have the streaming from the server to the client. Yeah. But it might be beneficial if we think that we go to have an again, you said the cost here is that you missed your once in a work, but it's not like you're going to get partially.
Yeah. And that's cost of the network. If there were networks highly unstable and there's much reorgs and people aren't really paying attention to them, then the network will probably stay unstable. People are not stable. If it's just like very localized, it's just a cost of
So it could be like these are the must-have implementations, and if we wanted to be the better client, we could add in this simplicity part. So that like your client is maybe better than others, so there can be some sort of benefit. Yeah. We talked about this. I think
Just
this
need to know what's being told.
yeah, so that's what we gotta just find like this.
Yeah, bare minimum, and then you can add on additional like optimizations essentially.
Yeah, that's the point. It's like this is the
requirements, yeah, you wanted to be better.
So let's bring the issue into the, so let's document that in the issue and we can address further that.
I think it's important to note that validator is the first user of the system. Obviously, they're a very privileged user and a very important user in the system. But like this API is the beginning. And the reason that when we're thinking about whether we want RPC or RESTful API or based on RPC and what this method is going to look like, we're thinking about our first user, the validator, but like this is extended into a general purpose API for other user applications as well. And so we're targeting our first user on these methods, but like the decisions we're making on how we want to expose these things to more protocols in the use is not just for the validator support.
Yeah, I mean, it'd be super useful.
Will a validator ever, you think, become like a deterministic algorithm, like kind of like if this then that, looking at these statuses, and kind of like take action based on that? Is that the idea?
That's what we're doing today, and then,
Okay.
and then I have a slide to describe that.
Okay.
Yeah, I mean that doc that we have maintained is relatively that without being so very.
Yeah. We'll be like, my thoughts is like, we'll become like stock trading, like where, there's like there's probably some people using kind of like the fundamental like trading algorithm, right? And then there are some people who have like maybe something like a high frequency trading algorithm. Like that's kind of like my analogy, right? Is like for validators, like if we have like a fundamental one, do you think that'll lead to like implementations of like validators that are kind of like doing their attestations, like
like I guess this is in some early research on definitely a different version of protocol we're looking at today, but they showed that there were certain strategies that validators might take in waiting to do certain things,
yeah,
reduce blocks and attestations to maximize profit. So there is some play there. That play is not necessarily good for the protocol, and not necessarily confident that everyone is doing it, but I expect people to. I expect most people to run defaults, because that is generally the case, but I'm sure somebody.
Yeah.
And we should be considering how it happens.
Yeah, that's where my head was at. Thanks for filling that in. Actually, I didn't have the words for it. Yeah.
All right, so let's move on. So here's the second part. That was fast about it. This is the second part, and this the following slides are more for the perspective labs. We can know architecture, what we will be signing, and yeah, hopefully we can get some feedback on that. So our beacon node has a few core components, and these core components we leverage from open source library. We have a persistent DB, we use PostgreSQL for that. We use the PTP for PTP networking layer. We have an RPC server, and we have a monitoring framework, which we use for Prometheus and Grafana. So those are some of the core frameworks that we have. So this is the beacon node architecture in a snapshot. And what's in the gray area is what's inside the beacon node. You have your P2P server, you have a bunch of services, the services such as sync, which handles syncing, RPC, which handles RPC requests, and the green the green square, there are services, they're more for state transitions. And then you have the purple one. The purple are just core helper libraries. They're basically what we implement on the stack. They're stateless and they're here. And outside the gray box, you can see this beacon node and this validator client. It's similar to the first diagram I showed you. The beacon node talks to other beacon node through the same service, and the validator client talks to the beacon node through the RPC interface. So this is just a high-level diagram. I'm going to go into detail in the next few slides. So what is a service? So the whole beacon node architecture, we use something called service injection. So it's basically a service chain. And what it means is each service is its own package, each service has its own lifetime, and each service is responsible for logging and dependency management. Okay? And the beacon node registers the service like this diagram. So you first start registering the each one chain service because we want to listen to the deposit contract, and then we register the transaction service because we want to get our core choice running, and then we register the state transition service, and then at the end we register the sync service because we cannot start syncing unless we have all the other information, right? And then each service has its own interface. So this is Go, and service can start, stop, and service can return status. So as long as you satisfy the interface, you can call your other service. And here are some of the service responsibilities, right? Each service has its own responsibility. For example, the sync service, it handles syncing with the other beacon node. If your beacon node restart, and sync service be like, oh shoot, I restarted it, I missed a bunch of blocks, now I need to get the missing blocks. And then you have RPC service, which help validators handle queries from other validators or from other people. And then you have a decision service, which its job is to aggregate attestation. Its job is to update the latest votes for running for choice. And then you have your state transition service, which does what you process blocks, and then you does the email processing. And then you have your operation service, which handles the beacon block operations. It stores those operations in a pool, so it can later be included in the chain. And then you have your E1 chain service, which listens for the deposit contract, it listens for the chain star, it knows when the validator registers. And then the purple parts are all peer functions. So for example, we have the core state transition functions. Those are just implemented to the stack. So whatever is in the stack will implement them. Those are, like I said, these are peer functions. They just stay in and stay out. And then you have other functions, and then you have third-party libraries, for example, like ELS, SSE, and those are there. So let's talk about optimization, right? And how there's a few optimization tips that we have done. We've added caching for the beacon node. So for example, we cache the cross-link communities because those get requested a lot. We also cache assessed blocks for the core choice. So we can just request the blocks we don't want. And then we cache attestation related fields. And we also cache state and blocks up to the last finalized epoch. So we try to avoid DB rewrite as much as possible. Alright, so here's to answer your question. So what is a validator lifecycle diagram? So validator is really lightweight. The validator's role is to propose and test block, and that's it. And it's responsible to manage its own private information. So validator, when you launch a validator, you first connect the beacon node RPC, and then you essentially wait for the chain start to log. If the chain start, great. If the chain hasn't started, you just wait there. And after the chain started, it checks in the beacon node whether it's active or not. If it's not active, then there's not much you can do. So once the validator becomes active, you will start update assignment. So one thing I recommend is validator itself has an internal clock. So he has a ticker, so he knows what every 6 seconds is, and he knows when there's a new slot, right? So at the beginning of the epoch boundary of the assignments, you find out, hey, what shard, what slot, what am I supposed to do? And then he does, and then starts making, and then you wait for that right time, and then he does the job. By doing the job, and he sends the block to the beacon node, or he sends attestation to the beacon node, and then he does it again every time. And this is essentially it. This is a validator lifecycle in 25 lines. It's basically you wait for the next slot, you log whether you make money, you lose money, and then you update the assignment, and you figure out your role, and you do your job. That's it. This is essentially a key statement of the validator lifecycle. All right, so jumping to the next part. So here, I want to share with you guys our past experience, what we have done, something that I have done to make our job a little bit easier, something I wish that I knew before. And the first thing we learned is profiling and tracing are awesome. Like they essentially help us on some of the critical bugs. And I didn't know so much about profiling and tracing until I met Preston. Thank you for helping us with that. And how do we collect good metrics and the alerts are nice. So I will show you guys a few screenshots of what I mean. And yeah, hopefully you guys, and let me know if you guys have any questions. So we have a Grafana dashboard which pulls the Prometheus matrix. So from this dashboard, this monitors the entire beacon state. You can see the last epoch slot, the last justified epoch, the last analyzed epoch, how many active validators are there, and what's the current state size. And based on this, it tells you a lot of what is going on in the beacon node. So for example, right now I have 542 active validators, but my EV size is 2.5 gigabyte. And that's concerning to me when I first see that. Like, oh shoot, why is the size growing so big, right? And you can see the state size, which is 60 kilobyte. I mean, I'm not sure if you can see this well. I will show the slides after, but right now you see there's a validator balance page in the chart. And you can see there's some validators that double the balance already. My question, how did you double the balance so fast, right? It could be a bug from our end. And then there's a chart on deviation, validator balance. So deviation meaning there's different beacon nodes and there's different validator balances. So how much validator balance do we deviate from each other from different beacon nodes? So that's something to tell you whether the beacon nodes are in sync or not. And then we track every beacon node's AD slots. We track, and we also track every beacon node's CPU and memory usage. Here are more charts. From P2P perspective, this is useful. You can see how many peer counts each beacon node has. And then you might be alerting if some beacon node has a lot more peer counts than other beacon nodes, you might be alerting. And you can see how many go routines we have. Sometimes we get a warning where our beacon nodes are slow because it's spinning up a tons of go routines. So we have to figure out why is there such a spike up. And then this is my favorite one. You can see how many rewards that beacon node had before. So for example, no one else besides beacon node 1 has 2 rewards. The one that okay, how did the beacon node 1 have 2 rewards? Okay. And then the last one is P2P message received. So you see how many P2P message the individual beacon node has received. So Prometheus is awesome. They have this awesome query. It's called PromQL. If you go to their query page, you can enter your query, and then you can just query the graph, right? So these two graphs are particularly interesting. On the left graph is the reward counter. On the right graph is the peer count, right? So you can kind of tell us that we can know reward happens. We can know peer count decrease. So something to figure out how we reward affect the peer count. Why sometimes we reward and we start dropping peers, right? So this type of graph helps you a lot in terms of analyzing the type of situation. So that was for overall we can know. So right now, if you want to but you want we can know at a time, you can use tracing. So tracing, we use open tracing with Jagger for the front-end UI. So this whole thing is a span of validators, sending, and authentication, right? So the two interesting part which I opened are this and this. So the first part is a validator request attestation information. The second part is the attested valid information is signed and sends it to the region node of broadcast. So there are two important steps. And you can tell from the first step, he did that with region node 1, and then the whole process took about 14 milliseconds. And then the second process, once he gets information, he signs it, it sends to the region node, and region node to process it. The whole process took about 260 milliseconds, which is okay, but you can kind of narrow it down to details to see how, like, with tracing, to see like, how each process goes. So this is flame graph. So this is called the profile that we use. You can tell different with different tracing. You can see how much CPU memory resource it takes. So for example, if you look at this guy, you can see okay, attestation handle attestation takes this much time, and then when you update attestation it takes this much time. It's because of you run a state transition. And in state transition took this much time because we had to process epoch, right? Okay, so what is taking majority of time processing epoch is essentially this function. It's this slice union function. And now we can go down to optimize that exact function. Why did we union two slices take that much time? So you know that's potentially the bottleneck of the processing epoch. On top of that, we also build a visualizer for analyzing fork scenario. So Rahul can build most of that. So we have the RPC method to export us in trace format, and then we display that into the UI. So the pink are justified blocks, and then you can see what blocks they built on that. You can see how many attestations, how many votes are there. So all these are live information. Those are from external peers. So if today you propose a block, as validator, your block will show up here. And with that, you can see some crazy scenario like this, right? You can see you have force happening, you have and then your latest block of built on what force, essentially. And this is the last slide. On top of that, we have an alert bot on my Discord channel. He warns us when there's too many epochs in functionality. He alerts us when there's not enough success rate for our RPC method. He also alerts us when there's too many roadblocks running, and we plan to add all of alerts on the Discord. So it's all nice if you get alerts in Discord versus looking into the log and find errors. So. Yeah, that's it. Anyone have any questions?
How are y'all doing chain sync? How are y'all doing chain sync right now? Like the new deep node intrusion test net?
Intrusion testing.
Yeah.
How do they sync?
Yeah, how do they sync up?
So we have, oh sorry, chain sync, that's what I mean. So we have a sync, we have regular sync, we have initial sync. Initial sync is when we can first start, or when we can went offline, when we can went offline a long time and come back, right? So essentially, when initial state, what we do is we request the last finalized state. Once we request the last finalized state, we know what the slot is, and we request a batch of blocks between last finalized state to the canonical state. And then once we process those blocks, we process, and then we can basically catch up from that point. And regular sync, we basically, we hear the latest head request. Once we have the latest head request, when we know which block hash we want, so we query that and get it back.
So you walk backwards, basically.
For initial sync, we walk forward. We start from the last finalized slot and we build to the latest slot.
But in the other scenario, you're just listening. So you were listening?
Yeah, we're just listening for the head of the chain, for the latest head of the chain. And then once we have the highest law number, then we have parity right now, we will request for it.
So do you do anything with, like having a trusted, statement hash to, to sync backwards to make sure that you're not being fooled by your peers, like a trusted?
I don't think you do that. We assume trust of big data, right?
Yeah, so, yeah, I think that's trying to describe this. We'll start from last common state and they'll also give us an expected state hash. So we'll request all the blocks, maybe from different peers in the network, and see that we still reach the same result.
Okay, so just how do you know that last finalized block is correct?
That's something that it's based on trust. We trust that's correct, right? That's the assumption.
Yeah, I think it's a bigger question for like each.
Yeah, that's like
right. So I was just curious if you like tackle that.
Yeah, we just handle that as a honest network.
Yeah.
So then I think if somebody were to come along with this network, that would be just because we don't handle it and yeah.
Any questions?
Are you guys thinking there's like open fees? Right? Because that's like compressed.
So what format is this in? So we're sending just like generic messages to say, you request all your various what is your state, so what is the slot and finalize the state action. So once you get that, then we can do the question. This is done over the TCP streams.
So I was asking a question specifically, like, if I'm hearing with one of my peers, and they go offline, what effect does that have on your performance and the ability to sync?
If they go offline for all time.
Yeah, like I say, hey, dude, give me the state, and they're sending it to me, and then I gotta use the room, and I'm like, hey, oh yeah.
Well, so we ask everybody in the room what your state is, and then go like sort them by what we think best, and try to go through all the successes. So if you told me you were best and then you gave me nothing, or like halfway through and stop giving me stuff, then I would just leave it for so we're working on that reputation system so that when we have some issues, we can properly do people. But we don't have the client things, so writing stuff.
I'm thinking about like sending you over like you like data transfer over UDP, but I don't know. Yeah, so it's more effective than waiting for a long period of time, since the state, I mean, like, all 3 minutes. Yeah, but it's a long time, you see the data. So if we're gonna assume at some point we're going to do the connection with the peer, after we establish that connection, and sync again, what's the difference? Like, it could be around, it could be, I mean, we need to be tested, obviously, like options, it's more effective to do that. If you're seeing states on any of multiple peers, you know? Yeah, every time.
What's the biggest problem we've had with testing so far?
The biggest problem, personally, with the one biggest problem for me is underestimating how long each things take, right? So we've had issues where people are processing more than 7 seconds, right? If that's the case, then you were kind of thought this each slot is 6 seconds. So then you get that cascade effect.
Is that because of the delay?
It's just because of optimization, our clients optimization, we didn't catch stuff, right?
So you think you're getting messages in time, basically?
We get a message of the time, it's just, there is a lot of offense where a lot of time the processing stack. Once we optimize that,
like there's a solution to that.
Yeah, this is right. But my advice is to start profiling early and find the model.
What you might have said it already. Are you using Flood Sub or Custom Sub or?
We use
It's custom stuff right now.
Does that work well? Like, is there like a definitive source?
We don't know. So my biggest pain with the test network is, at least when we started it, the lack of things we can see. So, custom stuff, like, does that work? I can't answer that. I don't know how it's not being the network. And so that's something we're just like trying to figure out. That's the thing. Fighting with Zach and trying to see their results. This is just something coming out last couple of days. So yes, if we're having these recognitions and things we can explain, things we think are taking too long, but we're not sure. That's like really what like adding this instrumentation and tracing all these things we're trying to figure out.
It's also good, like just based on we can set up a simple. It's one thing to do this on the beacon chain. We definitely 100% have to do that. Like, but setting up like a simple case, like the direction exactly going on, and testing a variety of topologies, latencies, sweeping parameters, and then finding where things to break, finding things that break down. Like that might be a decent place to start. I think that's like 4 or 5 machines. That's what we use. So.
If we want to like isolate, what's the what issues are arising actually with the protocol, and like what is the application? And the protocol guys are doing the application layer, and the layer, like the application layer guys are doing the protocol. So
if you're the same person, you have a lot of internal conflict.
Yeah, and that's what the name's John.
So, yeah.
Okay, that's it. I'm here, questions here, feel free to ask us any questions.
This event that we're having, the Road to Interop doesn't know that. So like, I would say that interoperability is the most important thing for us to get to the beacon chain. That's the very first thing that we need. First you need to interop with yourself, and then also our individual clients need to interop with each other. That's why I try to focus on that. I think for me, working on Ethereum 2 is like the space race, and there are lots of teams that are competing, even inside of E2. But I think it's best, makes the most sense if we cooperate and achieve, this high goal. So with that in mind, kind of the name Road to Interop was actually I'm wanting to interop, but also I have a plan, and that plan is to do kind of like what Johnny Gray describes as a lock-in. And so in July, what we want to do is we want to get together, we want to get all the implementation teams and some researchers, lock the doors until we run out of oxygen, and get our clients interoperable about a week long. So July 26th through August 2nd. Yeah. Big surprise. So yeah, July 26th through August 2nd. We're gonna do it in like sorry, I'm not really familiar with Canadian market, so and so so what we booked like this this is basically like a campground, right? Like a bunch of like cabins, and we booked that for like E2 implementers and researchers.
to kind of take us across the finish line. So, come during that time. It's kind of like if you're needing to implement a researcher, and we'll kind of like bring all of our clients into Interop. And Joe Lubin was very instrumental in that. We got to thank him for providing that for us. And so I look forward to doing that. And Johnny Ray's going to come up now, and he's going to talk about interoperability and like what are the check marks that we need to get to, so that by the time we get to this next workshop, this week-long workshop called Interop, what are the things we need to actually interop? And Johnny.
Testing. Okay, so I don't think this microphone stretches far enough. So in my beautiful handwriting here, I basically was like writing down some notes as all the teams were talking. I think all of us like sort of know, the areas of decisions, things that we need to actually agree on. In order for this like interop effort to be successful, especially in the way that we think that might be optimal, we need to make some decisions as far as like the first one I wrote down is like, hey, let's skip your discovery. Let's all start with like a static list of nodes, and we can just fire off from Genesis event that everyone agrees on, the same way that we do it. Like you could have Genesis event fire immediately, but you just have to load up a bunch of keys and make sure you're all set to go. But really, that's one thing that I think is important, because I don't know that we're all ready to handle discovery and tackle that. But it's going to buy us some time, before we can get like this minimal V5 spec that we can possibly start to implement. So I think that would be a good thing to decide on. Does anyone have a problem with that, an objection? Like, let's start simple. Like, say two teams are starting to interrupt, like, let's just have some known nodes and let's start, processing the beacon chain, doing all that stuff. See pros, cons, good idea.
So we're temporarily sacrificing part of the decentralization to get to parts where we can.
Yeah, basically, like we'll all spin up a finite number of nodes. We can decide on a topology or something, how they're all connected, and then just proceed from there. Does that sound reasonable? Like, do we want to go any further for that?
We standardize lockout, but.
Okay. Yeah. Okay. Yeah. That's a good thing to write down. Can you write it down? Yeah.
I think Antoine's working on that. The log output.
Yeah, there's something to see like standardized performance. So we know what each client is getting. And then we don't need to parse like individual log output.
Yeah, that's a good idea. I think there were some like issues created on different repositories, just saying like here's a proposed one. But really, like what I would like to see is like, yeah, it's like super minimal, like local specified, but really like we should be able to at any time like add any field from any log, any state, so just keep it dynamic. But like it just needs to be expressive so that it's very easy to parse.
There's probably like a few fundamental pieces of data, like timestamps, right? If we create it so it's like modular, then we can kind of just plug and play like different fields as we need.
Yeah. Okay. So yeah, logging. We need to standardizing logging. That sounds good. Any objections? Like, is it okay? The way we do it right now is we literally like every slot. We have several different implementations of like a data provider. We can spit it out and CSV based on whatever. We can stream it. But really, what we're just doing is just creating a pretty big log file. I think would be post processed.
So I heard that some people were proposed to like JSON now.
Okay, so what we can do is CSV, but CSV is part of like hierarchical data structures. Like, is there another?
We use floating views, it's kind of like JSON. We don't really care, like it's whatever, like logging the JSON is part of the problem. We already almost already have it.
Yeah, so meaning log, not necessarily what's like going on your screen, you know what I mean? You're just like watching the process, just like in the background. Yeah, like let's subscribe to, you know, at the end of all slot, state transition, like what, you know, what's our new like justified block, finalized block, you know, some of the interesting information that we might want to like look at, some block hashes, just to prove like, hey, we all got the same answer. So that's
But it doesn't have to be like blocks that are shown to the user. You just
no. It can write to like literally
like a dump.
Yeah, we dump to a file line by line in every slot.
Yeah, we don't. It doesn't like matter like what you did for now. Even. I mean,
Yeah.
like what you wrote for us.
Yeah.
Okay. So we could pull this out.
Yeah.
Okay.
So that way, like, you can just ingest it, like, rather than
Okay.
but it's just easier, like, rather than writing custom wrappers or parsers for each individual client or even the logic of their own algorithm. You can just, you know, standardize it and everybody has the same type of output and then do it at the end.
Okay, check.
Okay.
Okay, so oh yeah, sorry.
I think what's more important is to standardize what errors to log. Because one time
That's
you're
great.
logging 10 errors, one
Yeah.
time you're logging 5 errors, right? For example, in the spec, when there's a resolution failure, we should log an error on that. I think that's good, right?
Okay, so
that what do you log?
Let's take a stab at like what we think is important. Like, I don't know, I can write it down.
Error output, do you mean for consensus errors, right?
Yeah, or just like a certain spec.
Yeah, there's a finite.
Okay, assert or check arguments.
Yeah, like even since we're already dealing with RPC, RPC, whatever we want to express, whatever it is, with the validator client, you should probably start with errors there too, because if you pass it like an invalid index, right? Validator index, like what are we spitting back and telling that's an error? That needs to be standardized, or we're gonna go down the E1 road of like, you know, Web3 giving us 5 different errors depending on the client we connect to.
I mean, I think error standardization is probably a good idea. Yeah.
Okay, that's pretty more cool.
Yeah. Like, I think that the way I like to think, if we start thinking on how someone like the Web3.js team or EJS team would be ingesting our stuff, that's, I think, how we have to think about it. Because if we think about them, then we will solve our problems. Because they're the real users, right?
Well, we're talking about two different things now. One is whatever RC interface we have, like qualifying exceptions and errors versus qualifying the errors and things that a client might dump or announce.
Oh, sure.
Yeah, so this isn't like for users, right? These are like for debugging.
Yeah, exactly. Like when you were working with Zach, like we didn't have them parse our crazy output that's going on the screen. We just gave them formatted output that made things easier. Up the index, load the database query, all that stuff. We'll decide on all those fields. Like so, but if we generally agree that's the right idea, like we'll hustle, put a proposal up there, and then you'll have to sit with one. Okay, so I feel like we kind of skipped the topic. We're just going to start with just status nodes, right? So,
Just agree, maybe important is to like agree on the node list format for this.
Yeah.
So that would be something that you kind of have to agree on. Like just, you know, if you want to make the client connect to someone else, which format are you providing like the actual addressing or something? Like even if it's like, you know, JSON list of multi-address strings or something, just anything that makes it possible like to do it in a client agnostic way. Yeah. That's like good enough.
Yeah, that also lends itself towards like you know, cross-client bash runs, you know, and really searching for edge cases and stuff like that. That way you don't have to have parsers for every configuration file. So that's a good idea.
I like what the Geth does. It's like a just plain text TXT file and just static peers.
Yeah, that's actually good.
That was like so easy.
Yeah, it's.
You know, like I think plain text, like I'm opposed personally to like getting all crazy into like THT shit, like hashes, like just use.
We use normal right now. I mean,
Yeah, that's fine.
Yeah. Yeah, okay, cool. So I think we're good there. I think that, okay, so it looked like, yeah, Terrence went into validator IP, or API, and it seemed like he had a pretty well-developed, like minimal, like, I guess, API, so that we know how a validator is going to communicate, to a beacon node. Is that like the final minimal answer that we want to work with?
There's a PR open right now, and open reviews, people are moving to the PR, and some side of general direction is that we're moving towards a REST-ish API. And then there's certain messaging format that will.
Yeah, are they kind of two different things though? Like, I mean,
one is a protocol and one.
Right, okay, so first of all, like, is anyone gonna revolt if we use REST? Like, is there like a strong opinion?
I think that we should benchmark the different considerations so we understand the performance trade-offs.
We don't, the performance of these laws is almost is that they like the performance of caching certain things that you might be able to do with the performance, but not the actual like executing
That's true.
And it doesn't have to stay that way. You know what I mean? Like, I don't think any of us is gonna have a problem switching it. Like Prismatic, you guys already have gRPC, right?
Yeah, and we'll support REST just through gateways. So, I mean, we won't personally use it, but if you wanted to talk to our clients through REST, then I don't know.
Okay, cool. Yeah, okay.
And maybe export like these like the things that you've agreed on so far with the whole like error output and stuff. You just put that in the same REST interface. Like I said, would be really helpful.
You mean write them down right now?
No, I'm just saying like just put like if you have a REST interface, you need to just like put stuff there. Like put like standardize like the stuff that you're standardizing now, like errors and stuff or nodes or pure connections or whatever. You can put that on the REST interface.
Yeah.
It's easy to extend. That way you don't have to deal with like files and.
Yeah, okay, right on.
So if you haven't seen here from Jeff's arguments for the rest of the API, someone who's experienced firsthand living with JSON RPC, there's up there. And that issue, I don't know what issue it is, check it out. It's extremely convincing. It seems like a product proper.
For REST or for JSON?
For JSON RPC and JSON.
For this interface, is that, do we think that's totally necessary for interoperability? Do we need to have that sort of like what was JSON RPC? You don't think so?
Yeah, I agree actually. Yeah.
It's not. I mean, you could have a node that's validator better than.
Yeah, right.
As long as you keep the same protocol and same.
Yeah, just I think just start that one is like maybe not not totally necessary. So
I mean, we could never conform on a standard for and have a valid.
okay, so
It's that unimportant.
okay, so another interesting topic is spec version target. So I mean, just based on like the timelines we're looking at, like a spec freeze, does that bode well with like the timing for the Interop lock-in? Like previously we were like, hey, you know what, we're gonna first like freeze on 5.1, you know, and then Interop with one of the teams on that. But like we're finding, you know, obviously like 5.1 wasn't perfect. We've had to take some stuff from 6, you know, in order to make it work. Like, do we need to wait?
On what our perspective, like what we can do. 6.1, we have a whole host of additional test vectors that are released very soon, which will hit a lot of it. And so one of the big important things for Interop, from my perspective, is repassing these static tests. We have a good like local simulation. Are you able to communicate on a network with yourself? All those things are true, then sure, attempt to interrupt with somebody who's hitting the same spec.
Yeah.
But one of those things is we have a lot of tests, and for 6.1, there's going to be the first thing where we have a good like sizable number of tests. I expect probably in 2 weeks' time to release something that's pretty probably probably an 07, and then not wasting it, probably something in June, which would be an 08. Both increasingly having more test vectors and stabilizing.
Okay, so I just heard 07 is what we need to say for that.
If you're looking to do a lock-in at the end of July, then that gives you almost 2 months to get up to snuff those test vectors and do something.
Yeah, I mean, I like the idea of pushing it, you know, trying to do it, so.
Is there a drop dead date for the 07? Is there like a day that we're certain that it's gonna come?
By the last day of May.
Last day of May?
Yeah, and then we'll have another release of the last day. So.
Is there any disagreement about doing 0.7?
You have to arm wrestle Danny if you do.
I think just practically, if the date of this Interop lock-in is the end of July, then we should do it.
Does he have concerns with that time frame though?
2 months.
Yeah.
The test
I think y'all can get it in there, the 0.7 compatibility.
Yeah, 0.7 on the last one is going to be hard.
I don't know.
The question is
0.7 is the end of May, 0.8 is
in our
freezes.
Yeah, I don't think we want to do a radical rewrite until the final is out.
Oh, okay.
Because otherwise we're going to do a radical thing from 7 and 11, probably, especially if it's going one way.
Do you see a big departure from 07 or 08, or do you have no idea what that's going to look like?
Maybe doubt. How much do you think is going to change between now and June?
So the main thing, there's just its checklist, but everything there is relatively tiny. Yeah, the main kind of significant thing is basically that if the phase 2 proposal that I have ends up getting kind of accepted as a good idea, then it makes sense to merge resistant and crossing communities, which would be just like basically continuity, kind of basing something between 1.0 and
So just cutting and pasting, that's what I heard, right? That's guaranteed.
basically it's just like changing, you know. That's like fairly encapsulated.
Which version is everyone up to at the moment?
That's a really great question.
A lot of people are getting up to 6.1.
Okay. Does it sound like a big stretch to say that you can send it to 7? It's not that far away.
Yeah, 07 is not as radical as 04, 05, 05.
Okay, I'll buy that. So it still seems a little, okay, so 07.
So we won't get to it until we've seen it, but like.
No. Well, I think we do need to commit to it because if we're booking video, you know, like maybe it's okay to be conservative. Like, is it too late to push it back? I think that's a stretch. Like, I like the idea of just jamming on it nonstop and seeing what we can do with it. You know, you just get locked out and you can't install the girl set because you're not going to the jamboree. You know.
Well, I mean, we'll like I said, we'll try, but I can't tell you what we.
That's fine. I mean, same goes for us, right? If we were like, oh, we're gonna go from 0.4 to 0.5.1, and you know, we're still saying that, you know, I think it was like a month and a half now that we've been saying that. So, like, I totally understand that, like, you know, verbally committing to something versus like the realities of actually doing something.
I guess regardless, say 5 teams show up for this thing, there's probably value even at that point in like 2 people are on a 6-1, like pairing up and trying to get some work done, and 2 people are in 7, pairing up and trying to get some work done. So I mean, we can have what we expect to
get to that point, but we can also play by ear.
Yeah, okay. Like we had a robust schedule for today, and then like 30 minutes in the morning, I was like, let's do it by ear. So yeah, I'm good with that. Okay, so spec version. After DVD. Spec version.
I mean, I think we pushed for 0.7, right?
Okay. Just call it 0.7. So, alright.
Okay. Okay, so this is something that I was talking to Felix about, like during the break. He might be better explaining this, but essentially the idea is like if we could take like a simple minimal wire protocol. Like obviously, like not all the teams are on, are using the PDP. We think that's actually okay. You can form on a wire protocol, and some of us are going to have to build this up from scratch. But that's not, that's not an insurmountable task. That's not, crazy. But what we'd like is if we could do that, and then we can still talk to PP. That doesn't require like all the teams that are already invested in the PP to start over. Like, I'm not trying to ruin anyone's day, but it seems like a possibly a viable way for us to get those copies. Felix probably has a little bit better, like, more concise or better way to explain it. How do we feel about that? How experimental is that? Antoine?
I think the point is to pull out the minimal wire protocol, regardless of the tech, just to have an isolated time frequency. That seems reasonable. I do, so given that the JavaScript DB implementation has custom celebration as of last night, is the main blocker on the DB is concept compilation, the Java implementation?
And minus 2, right?
What?
I mean, this is right? Like, we could use our interface. Okay.
Yeah, okay, so we have some options, I guess. Felix, you want to talk about?
I don't want to go on for too long, but it's really.
Yeah. No, I just think that.
Okay, I'll try to explain the idea. So I guess the main problem with like networking interop so far is just like nobody was really like agreeing on like what the actual, even if everyone would be using libpdb at the moment, you'd still have to agree on like which configuration of libpdb you're going to be using. And so I guess what's kind of missing at this point is just like this is a specification of the actual bytes on the wire, like that are going to be used for ETH2. Like, if that specification is basically just re-specifying what the P2P does, that would be fine as well. Like, it doesn't, it just, it's, if you're making a new protocol like ETH2, kind of makes sense to have a specification for the networking of ETH2, regardless of the software stack that you use to implement, or, it doesn't, these are two separate things. Like, you can say we're using libpdb, but it's just the software. Like, you need an actual document that says like what the software is supposed to be. So, and I mean, but obviously, like like making a really complicated specification that encompasses all the layers like encryption, encoding, and multiplexing different things on the same wire, and all this is complicated. So we don't necessarily want to start out like a really complicated document that specifies everything. So that's why the idea was to just start with something simple, something you can actually implement from scratch in like 2 days. And it wouldn't be necessarily PDP compatible. I've seen some good work, for example, like on the side of Artistline, where they just basically work with the Hobbits protocol, that you can implement that in 2 days. It's like a really simple way, like talk to another client, and you don't necessarily have to invest like in the software stack or debug it, or and at that point, just when you're just trying to do like interop testing with another client, you don't necessarily care about the protocol being optimal. Like, I mean, there have been a lot of discussions over the last year about the optimal protocol, like how to really make broadcasts super fast and minimize the amount of bytes you're transferring on the wire. But none of these things really matter if you're just trying to do some Interop testing. Like really all you want to do is just like talk to the other client at all. Like, so that's why I kind of advocate for like maybe just starting like a little document in the E2.0 specs repository that just says, okay, this is like the minimum wire protocol that everyone must implement. And it's really like, it's a really simple step, but once you have that, you can actually talk to another client. Like, and then you can just see, is it failing, is it not failing? You can just treat it like it was, you know, like your client. But there's something else on the other side. There's a tremendous amount of value in just having like another piece of software on the other side of the socket, like sending you stuff. Like you shouldn't underestimate the power of that because it's going to show you like bugs in your implementation, race conditions in your implementation, you know, timers for environment, all that kind of stuff you can see really easily if there's just some other piece of software where like sending you stuff in the wrong order or whatever. Like so I guess that's why I've been pushing for maybe like even for today, like having like a breakout session later where we just kind of think about like what would be like a good way to start that simple document that just says, okay, this is what you must implement in order to talk to another client. And then I just really hope everyone can get on board with that. So are there any concerns about this, or is it interfering with anyone's plans, or like is it too much work? Or like, I mean, these are the main concerns, right, on everyone's side. Maybe it's going to be too much work, or it's going to be distracting from the main effort to like, I don't know.
This is a minimum interval of the wire protocol.
Yeah, pretty much. So the goal there would be like maybe before the lock-in to come to consensus on some document. And then you have to implement that maybe hopefully before the lock-in, because you don't really want to come to the lock-in and like having to start your implementation then, because it's going to take you like 1 or 2 days to get there, and then you know this is going to be locked in longer. Like, I guess the goal for the lock-in is, you know, like to leave as early as possible. Like you kind of want to be gone after like 2 days because everything's working, right? You don't want to spend like the rest of your night there. So
Short life.
What is the status of wire protocol? Have we ignored it?
I mean, so there's a list. So at the moment, there's a high-level spec. And the high-level spec, it just says, you know, which messages you can exchange with others, but it doesn't really say like how these messages are transported. It just links to the libp, and then, you know, you're supposed to use that somehow. Right? So, and that's like how. I think it's very important for like the long term to come up with like a good and secure and performant wire protocol, like a good and secure and performant gossip mechanism. These are like really good goals, but they're like not important at all when you're just talking Interop testing. All you really want is just, you know, like, here's my IP, talk to me. Like that's what you kind of need. Yeah, so I guess this is like the case for Hobbits, and it's in the Hobbits is like this is what it's made for. So we could just agree on Hobbits, it would be great. I don't know, but you know, like maybe someone has concerns or like doesn't like it, or there's always something. I mean, fair point for Hobbits is that, you know, there are like 40 implementations of it, like in the repo.
There's even a bash.
Yeah, there's a bash one. Like if you're ready to play in bash, you can like
The batch one just calls it Swift implementation.
Okay.
I wrote that to troll.
Yeah,
I fixed it. Oh, wait, you made a real one?
Yeah.
It doesn't involve soul. Correct.
So it's just kind of important to know that even if we're advocating for Hobbits or something, it's not, you know, the plan isn't to, you know, like make Hobbits like the ultimate wire protocol for E2 forever. This is supposed to be like the stand-in thing that we use now to just, you know, debug the software. And then whatever comes out of this, I mean, there are many ways forward from that. We can evolve this minimum spec into the final spec, or we can just replace it later with a better spec, or you know, with something totally different. But it's like we'll see then. But the current goal is just to get to Interop as possible, I guess, on multiple fronts, and so that will be the part of it. Cool.
So why don't we just define like an interface for it, so then we can plug and play whatever the hell we want underneath. Right, so if we define like the upper layer, the like most high level P like document for it, then we can just use Hobbits underneath or switch to plug setup, whatever. What?
We have that. That's the spec. That's the currently the policy. That's the really fun.
breakout session, like, might possibly help, like, clear up maybe like what's really involved. Like, I mean, what you're saying, like, totally get it. Like, I think it could be simpler than what it initially sounds like.
No, I've just ignored the word for the content, so no idea what's going on.
I mean, Antoine will do it for everyone, so.
We're gonna pass a hat later.
Can I do the thing?
Oh, yeah.
No.
Same.
Okay, so wire protocol. Okay, P2P.
Okay, so yeah, that was part of the solution. I spazzed out and like put dash there. So really, it sounds like we have a lot of decisions that we know that we agree on. I think we do need a breakout session just to like dive a little bit deeper into the network stuff, just to make sure like we're not changing people up. Like, let's make sure that like we can agree on that. Like, it's reasonable. There are also like ways to get outside health resources. You know, everyone has a lot to do. So that's basically it. So anyone else have anything to say?
I'll say once again, I know we're racing to Interop, but to get there, we need to race towards having our own local testing, race towards passing static vectors in the same.
Yeah, that's
something
that-
towards having a local
Yeah.
simulation on our network, having our own clients on our network, and then if we skip any of those, we're gonna have a bad.
Yeah, those are the Girl Scout cookies you have to sell first.
Yeah, like you quote me, say it's but I talked to college guys, and they, even with one client, brought their client's network too soon. They didn't have a good simulator, they didn't have a good this or that, and they said they wasted months doing that with a single client. So lay the foundation for don't. Even if we get to the end of July, we all go and just have on our own like clients talking to ourselves, we're all in the same company, and it's great. And that's just what we have to do. Like that might just be what we have to do, but like don't skip any of those components because we can't just waste a shit ton.
Well, we're gonna this to be automated. That's
Great. Yeah. So we'll do that. Good. All right. So you still. All right.
Okay, I think that's it.
Okay. We're gonna take like 10 minutes, right? Go see for more.
So I will be talking about ETH2 phase 2 and some of the thinking and proposals I've made recently around that. So just to kind of give a quick overview of what the different phases are, there's like 4 major phases of ETH2 that have been seen so far, where phase 0 is just getting the beacon chain and proof of stake figured out, and that's something that we've been talking about. It seems like it's coming close to testnets, and we're talking about interoperability and getting this back to 0.7, which is great. There's phase 1, which concentrates on sharding, but specifically sharding of data. So that's when the 1024 shards sort of come online, but the only thing that you get in the shards is that there's just blocks of data, probably about 64 kilobytes or 32 kilobytes coming every 2 seconds. And these shard blocks would get combined would have their headers and blocks combined together into crosslinks. The roots of the crosslinks would be published into the beacon chain, and the beacon chain would be kind of gathering together all of these blocks and keeping track of all of these blocks and all of these different shards. But these would be blocks just containing data, right? So if you want, you can use it for stuff. If you want, you could use it in a bunch of ways, and I made a bunch of presentations about how you can do things like ZK rollups on top of it, so it's not that bad. But it doesn't give you smart contracts and execution. Phase 2 gives you smart contracts and execution. So after phase 2, ETH2 will basically be kind of fully functional. And there's also a phase umbrella term for upgrades we might want to do after phase 2, which could include things like CBC, Casper, Starks, etc. So challenges in phase 2, right? So one of the major challenges is cross-shard communication. So the model does kind of start thinking about phase 2 as to basically think of it as you have these different blockchains. All of these different blockchains have their own state, they have their own blocks, they have their own transactions. They kind of work like 1024 copies of each one, except the protocol is better in a bunch of ways. But you still want the ability for these shards to talk to each other, right? And like a number of people have raised the kind of very important points that it's likely that a very large portion of activity will end up being a cross shard, right? So if, for example, we see ETH2 as being used for people to send money to each other, then most of the time I will not have money on the same shard that you do. And in fact, if it is the case that I always have money on the same shard that you do, then that means everyone has an account on every shard, which means you're not actually scalability gains. So you want cross-shard communication. It's important that it's efficient, and it's important that it's very fast for usability reasons, right? So we want something on the order of a few seconds, not on the order of a few minutes. Problem is that with the way the beacon chain is designed, shards only learn about each other's state through crosslinks, and crosslinks only happen once every 6 minutes. Now, you might ask, well, why do crosslinks happen once every 6 minutes instead of happening once every 3 seconds? And the answer basically is that it's a scalability limitation. So if we were to do a blockchain where we had crosslinks of every shard hitting the beacon chain every 3 seconds, which actually is what some of the really early proposals from 2015 looked like. Like if you do the math, right, and we're basically talking about minimum size committee of say about 250 nodes, multiplied by 1,000, 250,000 signatures, get verified every 3 seconds, and the data load on the chain just goes crazy. So if you want that speed, then you basically need super quadratic sharding. Super quadratic sharding is really complicated, and we probably don't want to do it. So we expect a large fraction of activity to be cross-shard, and base layer cross-shard communication looks like it's only happening in 6 minutes. But we want people to be able to talk to each other and do stuff between shards faster than 6 minutes. So how do we do this? So the solution that I first recommended a few months ago is this approach based on what I call optimistic cross-shard state objects. And it's kind of best described by the diagram here. So just walking through the diagram, right? So the top is one shard, the bottom is another shard. So imagine Alice has some coins at the top shard, and she's sending some coins over to Bob. So what Alice does is she burns her 5 coins on the top shard and generates a receipt. And the receipt basically says 5 coins to Bob on this other shard. So now you have a receipt. And if you do things the normal way, then basically all that you can do is you can wait 6 minutes, and eventually after 6 minutes, the crosslink containing that first block with root R will be included in the beacon chain. So the beacon chain will know about shard A up to that point, shard B will know about the beacon chain up to that point. So through that sort of indirect link, shard B will know about shard A up to that point, shard B will be able to recognize that root that the Merkle proof is rooted in actually is the legitimate root, and then that receipt can be verified and the coins can go to Bob, right? So far this is like standard stuff I've talked about since 2015. Now here is what we're going to do. We're going to include the Merkle proofs in the receiving chain faster than the root gets can get verified. So we're going to include the Merkle proof, and we're going to process the Merkle proof before we know whether or not the Merkle proof is fully valid. So here's how we do this, right? So time t equals 1. Alice, this on the bottom shard has 10 coins. Bob has 20 coins. Charlie has 30 coins. Time t equals 2. The Merkle branch gets included on the bottom shard. but the bottom shard does not yet know whether or not the root actually is legit, right? So what we're going to do is we're going to say, well, we can't obviously give Bob 5 points because it could be fake. So we're going to give Bob a state where the state basically, instead of being one number, it just says 25 points if R actually is, the root of the Merkle branch actually is a legitimate root, otherwise 20. So Alice still has 10, Charlie has 30, Bob has this funny superposition expression. In a time t equals 3, where the chain bottom shard discovers whether or not the root is legit. If the root is legit, then Alice, then Bob has 25 coins. If the root's not legit, Bob has 20 coins, right? So when you're worried about the root, you can kind of collapse the superposition. Now, the fun thing about this is that two things. First of all, if Bob has a wallet, which is privately aware of the state of shard A and shard B, then even though the state says Bob's balance is 25 if R else 20, Bob's wallet knows that R is legit, and so Bob's wallet can just show 25 after 5 seconds. So Bob's wallet can learn that Bob's balance is 25, and he can just show 25. So from a user experience point of view, it looks like the state transition happened in 5 seconds. Now the second fun thing is that suppose Bob wants to send 22 points to Charlie, and suppose Bob wants to send 22 points to Charlie immediately after Bob receives those 5 points before the root gets discovered by the bottom shard. So what we're going to do is Bob is just going to send a transaction. The transaction is just going to say, hey, I think R is true. I want to send 22 points over to Charlie. If that happens, then the state of the chain becomes Alice 10, Bob 3 if R else 20, and Charlie 52 if R else 30. Right? So now Bob and Charlie both get compound expressions. And at time t equals 3, if that root is correct, then Alice gets 10, Bob gets 3, and Charlie gets 52. So the nice thing about all of this is that if Charlie also has a wallet, and Charlie is also aware of the shard at the top, then Charlie can also see his wallet, his balance as being 52. So yay, it looks like we can sort of pretend that we have 5-second cross-shard times on top of a system that actually has 5-minute cross-shard times. So this kind of optimistic guarantee that we get is theoretically fun. It does not depend on liveness assumptions. It does not depend on assumption like any weird classical style exit games. All it depends on is just that the R actually being the root in the top shard that actually gets included in the beacon chain of finalists. So far still stuff that I've talked about for a few months now. But this might not be the best. There's a fairly big design space inside of this mechanism, right? So the reason why there's a big design space is basically that you don't actually want, the number of dependencies you could end up having, even if they're just roots, is pretty big, right? Even if we just talk about every shard learning about the roots of every other shard, well, one root is 32 bytes, multiplied by 1024 shards, 32 kilobytes, and boom, we're using half the block space just for roots. So that's not the best. Maybe we can adopt some structure where it takes multiple steps and shards in order to go to each other's roots kind of optimistically in 2 blocks, and then you need some longer proofs. So maybe we can make a root that summarizes roots of a bunch of shards. So now we're kind of doing super quadratic sharding on a higher level, which is cool. But it's that's one way to do it. There's 1,000 different ways to do it. One other way of doing this that I mentioned is instead of you could actually have shards contain lifelines of other shards. You could have anyone being able to just submit whatever dependency they want. You could require people to stake to submit an optimistic root. So there's this big design space. We don't want to be too opinionated in it, and if we kind of commit to something too early, then we might be sort of digging ourselves into a suboptimal hole. We don't want to do that. So that's the first problem. Here is another challenge that's kind of been nagging at me about the Ethereum design for a long time. shard state, right? So if we assume each of these shards is basically like an Ethereum chain, then it's going to have state. And state is big. So the Ethereum state is maybe 10 gigabytes. And thanks to Alexei, who helpfully provided some numbers on when exactly the accounts and storage keys got touched, I made a kind of very quick heuristic measurement, which is based on storage key data from block 0 to 5 million, which basically says if you set it so that storage keys only last about 2 months, or only last 1 month, then you're cutting the state size by about 80%, and if they last a week, you're cutting state size by about 95%. So it's like rents can really reduce the state size, and rents can reduce it by quite a bit, but the TTLs have to get very short in order for the state size to be like actually small enough to be efficient, right? So one way of thinking about this is that you can get numbers from Alexei and like Yankees awesome, and we can like actually calculate, like try to calculate what the state size would be if we had some rent scheme. There's also another more sort of mathematical way of looking at it. And the mathematical way of looking at it is basically this, right? So let's suppose that the time that the persistent committees get shuffled is, we'll call it T1. And that's right now, it's 9 days, it could be a bit more. Let's suppose the TTL, so the amount that an account that gets created survives, we'll call that T2, and it could be a month. If you create a state object, then the amount of times it will have to get downloaded is basically T2 divided by T1, right? It's the number of persistent committees that will have to download it before it disappears again. If T2 divided by T1 is large, then creating state objects becomes really inefficient, and we have to just charge a new future event for it. So so one problem is just that like you have to have all this infrastructure, and it constrains the kinds of rent schemes that you can do and all of these things. Another problem is that this whole design requires this split into two kinds of committees, these persistent committees and cross-link committees, where persistent committees store the entire state, cross-link committees don't store the state. And basically, it's actually 2 times less efficient than it needs to be, right? Every block, instead of being verified by 200 nodes, validators gets verified by 400 validators, and we're not actually gaining any security as a result of that. And the second problem is that this is a centralization risk. And the reason why this is a centralization risk is basically that the amount of things that a validator needs to run doubles, right? Instead of one shard per 32 ETH, it becomes 2 shards per 32 ETH. And the point at which it kind of hits the top of the curve, so the point at which like you have to pretty much store the entire chain is twice as low instead of being 32,000 ETH and 16,000 ETH. So it would be really nice if we could just get rid of this weird 2 kinds of committees and we could just have one kind of control committee. So the approach here that I'm thinking about is basically like a kind of phase 2 abstraction, right? So the goal that we're going for is to try to minimize complexity of consensus layer state execution. So we're trying to like basically minimize the complexity of the doc that consensus layer nodes have to read it. And it seems like it should be possible to make that doc be only in 200 lines. But there's a bunch of ways to do it. And the idea is that we want any desired environments that we build, like most of the actual infrastructure, to be built as kind of layers on top. Right, so these layers on top don't have extra assumptions. So these are not like plasmas where you have exegames and operators. They're not like state channels. They're more like programming languages than they are like plasma. They don't actually like introduce more assumptions, but they are sort of the place where you can experiment with different ways of setting up these environments and then operate them over time without making any changes to consensus. So Casey wrote this wonderful minimalistic, ultra minimalistic proposal a few months ago, which he called kind of phase 1 and done, which he basically suggested that you have smart contract execution happen only on the beacon chain, and all that shards do is they're responsible for holding data and verifying availability of 20 megabytes a second of data. And the way that 20 megabytes a second of data availability translates into higher scalability for real users in practice is basically through zk roll, right? So the idea would be that Ethereum would just become the world zk rollup verifier. And everyone would do things inside of these rollups, and the base chain would be verifying a bunch of snarks and starks. And yay, we would have like somewhere over 1 million transactions a second if there's enough provers running, and like that's what Ethereum would be, right? So if all you want is to like have a big number and you want 1 million on-chain transactions a second, then like okay. But there are some weaknesses here, right? So then a couple of weaknesses. One of them is that actually doing proving for a zk rollup is not efficient unless you have a Stark-friendly hash function. And so you don't want SHA-256. You want Peterson is like probably like the simplest you can get away with. You probably want either Mincy or one of the fancier ones. And zk rollup proving is likely to be very inefficient with general purpose computation. So if you want a full-scale EVM, you're just going to have a hard time making proofs of state transition to a full-scale EVM. And so even if it looks like you get 1 million TPS on paper, in practice it's like, you gotta wait for like Jihan Wu to come up with basic provers, and then he's like, we're all relying on him to run the chain. So that it's not the best, right? So solutions. So one thing that you might notice is that there is a way of generalizing phase one and done slightly in a way that doesn't really change the model at all. And the approach basically says, well, we know if you are making a shard block, we know you already have to calculate the hash, the SSC workable root hash of the data. Well, instead of just requiring them to provide the workable root hash, let's allow them to commit to an arbitrary reduction function. So this is just WASM code reduced. It's a function from data, which would be a 64 kilobyte block, going to 32 bytes. Now, clearly, workable rooting is just a kind of reduction function. But we can talk about other kinds of pure functions. We can talk about pure functions that include signature verification, that do MIMC, that do calculations of parts of state transitions. So we can, just by doing that one thing that technically doesn't change the model like at all, we could just gain a huge amount of power, right? So this is one sort of step up. Now, I would argue that we want to do one more step up that changes the model just a little bit more. And if we do that, then we basically get everything we need. So the approach here is, the problem that we have, right, is that that kind of approach still requires a lot of complexity to happen on the beacon chain, involving just computing application states, like actually processing state transitions, actually like doing whatever you want to do with all these reductions. So what we're going to do is we're going to make the reduction function a little bit more stateful, right? So this is still a pure function, except instead of being just a function of the block data, it's going to be a function of the block data and the output of the reduction function the last time there was a block in the same shard with the same reduction function. So shards are going to be slightly stateful. They're going to store basically this map of what reduction function to last output. And what we get out of this is we get the ability to sort of thread state through blocks, right? So we get the ability to kind of have these hashes and sort of thread state by just kind of keeping this hash passing through these blocks that have the same reduction function with where you can imagine these hashes being, these 32-byte states being workable roots, and the reduction function basically doing things like workable proof verification or like basically running a stateless client of a much larger state. Now, iterating a little more, how do users deposit and withdraw Ether, right? So first of all, we'll think of these, we'll give these reduction functions a bit more power, and we'll say, on the beacon chain, we're not just going to store the function as a piece of WASM code, we're also going to let them hold Ether. Now, we're going to rename reduction functions because they're not pure functions anymore. Well, they're pure functions attached to a balance. Well, I call them execution environments in the documents I've written up so far. I'm going to propose, well, Dan Robinson proposed, and I like the proposal of calling them threads because it just sounds nicer than and like shorter than execution environment. And the idea basically is that if you as a normal user wants to hold ETH, then when you withdraw your ETH from a validator slot, you will like basically send your Ether to a thread, and at the same time that will generate a receipt, and then that receipt can be sort of verified inside of a thread, and it's the state inside of a thread that determines who actually is entitled to the ETH that theoretically belongs to that thread. So it's this sort of two-layer system, right, where like there's threads that are sort of the highest level owners of ETH and the state roots, and then you have these like lower level, like basically everyone else that just owns ETH inside of the thread. Now, so what we're going to do is we're going to change the reduction function again, and we're going to give it access to the beacon chain. Now that it has access to the beacon chain, we've enabled two things. One thing that we've enabled is the ability to verify these receipts that you create when you withdraw from a validator. So now you can deposit your ETH to a shard. And the other thing we've enabled is the beacon chain contains crosslink roots. Crosslink roots contain shard state roots. Shard state roots contain execution results from other shards and other threads. So we've now enabled cross-shard communication and cross-thread communication. So to support withdrawals, basically, there's two ways to do it. One of them is to have the reduce function just provide a list of withdrawals, and then the crosslink has to summarize them. Another approach is that the thread would specify not just a reduction function, but also a withdrawal verification function which would basically just verify some special type of workable proof against the state and be able to do withdrawal that way. So there's a couple of ways to do this, right? So stop for a minute now, and I'll just probably accept questions about the basic framework, and then I'll start talking about implementations. Okay, questions. Yeah, I was about to say that. Yes. Yes.
So it's like during like one transaction that is called, is the call to the other execution environments like a static call? There's no way to like make a state mutation call without having like the receipt generated and then having access to another execution environment?
Yeah, basically. So in the proposal I made, like basically the only way that you can call the other things is through pure functions. So the idea here, right, is that in the proposal, in the document that I wrote, like I kind of overloaded like WASM contracts on the beacon chain to serve two functions. One of them is as execution environments, or like I call them threads here, and the other one is as recompiles. So the idea here that I'm thinking about is that you really want to actually use compiled WASM rather than interpret it as much as you can for fast, speed requiring computation, because WASM is 90 times faster if it's compiled. But you can't have compiled WASM inside of shards because cross-link committees are not going to store anything, and so they're going to have to compile everything in real time, and compiling things in real time is slower than interpreting. So user level code will have to keep being interpreted, but the idea would be that if there are specific operations that people use often, could be cryptographic operations, could be account code, could be a bunch of things, then you could publish them onto the beacon chain. You have to pay a very high fee of like a few $100, but then that's a piece of code that then anyone can just call as many times as they want. So it's kind of overloading the role of on beacon chain WASM code between the purpose of being this reduction function, the process of blocks, and being this accelerated function. So there definitely wasn't the goal of enabling one thread to call another thread inside talking about changing framework within the context of this framework, it would probably introduce more complexity than it's worth to start doing that.
Okay, yeah, just like envisioning, like if there's a token execution environment, I want to transfer tokens, it might be simpler to like directly call that out, the state for that, the token environment, you say it rather than having to like manage receipts on like an Ethereum environment.
Right. No, that's definitely a good question. Yes.
So in the Alice and Bob example, you were talking about like creating a reduction of the transaction, right? I think it was like 25 plus, minus, etc.
Collapsing the superposition, yeah.
Right, yeah. Is that possibly an attack vector? I mean, I imagine that you could overload that with a bunch of conditions, right?
Yes, that's a great question. So in the design that I came up with, this was the Python code I wrote a couple of weeks ago. The approach that I had is basically that every transaction has to specify a dependency, and then that transaction would basically only be able to affect the state of accounts that, like the version of the state of accounts that is sort of in that universe. And so that way you guarantee that the effect that a single transaction has per account is O of 1. So there's no sort of quadratic log vulnerability. The other thing that I did there was you can't just like put whatever conditions you want, right? The idea in the proposal that I implemented is that the chain state has this list of kind of canonical forward dependencies, and there would be some mechanism for providing a canonical forward dependency. Like this could be, like canonical forward dependency is basically a kind of optimistic guess about what the roots of all the shards are. And you could do this with a light client mechanism. You could do this by just like having an ether staking market. There's a bunch of ways to do it. And you can only use things that are in this canonical forward dependency list as dependencies for a transaction. So that further sort of constrains things. And then the third really important thing is also that as the shard gets beacon chain roots and as it learns about basically whether or not its like earlier optimistic guesses are correct, you can kind of collapse some of the dependencies and you can just like take them out if you know that they've been satisfied, or like delete an object if you know that it's based on dependencies that are wrong.
Thank you.
Maybe the motivated, other than just reducing the complexity of the instance layer, like why we would have maybe two different execution environments of threads might be, or maybe how kind of upgrade just.
Yeah. So this is part of what I wanted to talk about with implications, right? So this isn't even the full list of implications, but here's a couple of them. So one of them is that you can reduce the one kind of committee, which is cool. Another is that there's no concept of like significant consensus layer state. There's just these 32-byte things that get passed around inside of shards. And state becomes a kind of thread layer concept. So basically, each thread would have threads would generally be sort of stateless clients for this much larger concept of implied state, which could be significantly bigger, but that's not something you need to care about at all unless you're interested in that particular thread. It allows for a lot of abstraction because it means we do not have to make consensus layer decisions on a bunch of things. So we do not have to decide on Merkle tree algorithms. We don't have to decide between sparse Merkle trees, AVL trees, whatever trees. We do not have to decide on whether we're doing Merkle trees at all versus other kinds of accumulators, like something involving RSA accumulators or weird Peterson magic. We don't have to decide on whether we're snarking or snarking witnesses because that's just an execution environment level decision. We do not have to decide on whether or not we're doing rent. And that can also be an execution environment, thread environment level decision. And threads might still want to have rent, basically because a thread has bad user experience if its internal state is 50 gigabytes in size. So there's a design space there, right? But questions, how do fee markets work, who stores these kind of thread level states, and the other big one is like how do you do upgrades? So I will talk about those one by one, and upgrades are sort of a bit further already in the slides. Yes.
So, the example you gave is kind of a unidirectional state change, and then like the balance is changing on here, and like that, of course, you kind of stop hearing after that.
Yeah.
How does it work under the bidirectional scenario where I make a call and I'm listening for a response?
So this is like what we call synchronous cross-chart communication. The bad news is it's much harder to do, but I'll talk a bit about the possibility. Yeah.
It might be helpful to elaborate just a little bit more on where the reduction function comes from specifically.
Right.
Yeah.
So the idea basically is that on the beacon chain, there would be a set of these WASM codes. And you could publish your own WASM code, but there would be a high fee to it. Like the number of trying to anchor is like hundreds to low thousands of dollars. So the goal would be to have just a fairly small number of them. And basically a block proposer would have the ability to choose like which one of these codes they're making a block for, right? So now one possible way to extend this is that you could even imagine a block having like up to 2 or 4 whatever components, and each component might even be like under a different environment. So there's potentially opportunities to do things like that. The idea, basically it is just a block proposer's choice, like which one they're going to use. Like naming is still kind of like there's no perfect name for these things, right? Because they are kind of pure functions, but they're also these basically state transition functions. But they're also responsible for this kind of part of the state specific to themselves. Yes.
Sorry, I have a really dumb question. So when you're talking about these reduction functions, so in which context would they actually run?
So they will be good point. They will be run by the shard node, by the committee that's executing, that's verifying that particular shard block.
Right. So you like one reduction function per shard? Is that what you were implying?
So each block would specify the reduction function. So,
right.
So
one function per block per shard.
Yes. Now, as I said, you could do instead of 1, you could do 2 or 4.
Like, how would they be bounded in terms of execution time?
There would be a guess on it.
Right. And wait, one more question.
Sure. Okay.
So, how would you who would decide which reduction functions you want to use?
The block proposer does.
Right, and you wouldn't, but I mean, how would you prevent the proposer from using a bad one?
Introducing a bad one, right? So let's suppose that there,
you find a bad ones in the scenario because the proposer could choose an arbitrary function.
Well, it has to be one of the ones that's on the beacon chain, but the beacon chain arbitrary wasn't.
Yeah. So the function has to be registered on the beacon chain before you can use it.
Yes.
Right. And how would you vet those functions anyways?
I mean, you basically don't, right? It's just code, and it wasn't code. It's guaranteed to give some.
Right. I mean, who would put the function there?
Anyone who wants to use it.
For example, the Ethereum Foundation and this group would create some sort of thread or execution time with regard to the function that likely would be launched with and formally verified audit, et cetera. But other players might come in and do their own auto create.
So if hypothetically, if the evil proposer decides to just publish a thread execution function onto the beacon chain that's just totally random or pathological in some way, then Eve has the ability to create a block that gets executed or using that function, but then that's all happening with that environment's own state, so it's not affecting anything else, and it has the output, so it's just the equivalent of kind of.
Right, and then they have to pay for that time.
Yeah, they have to pay for the time.
Right. So that's as long as they are already paid, any function's fine.
Yes, exactly. Yes.
It's
seems like the logical outcome of this is that there's very little opinion about how the execution happens in these threads. That whether they relate to the way the Ethereum smart contracts execute today or any other environment, that they could be kind of any kind of state that just needs to be ordered by a single chain. Is that somewhat like is that some way of approach?
Yeah, that's definitely the idea. So like you can, on top of this, you can create a thread which behaves in a way that's extremely similar to how Ethereum behaves today. Like you could literally create a thread which is a stateless client for ETH1, and that's basically just is my proposal for where ETH1 would eventually end up under this setup. But you could also create threads that represent UTXO systems or like ZEXC or like some weird cryptographic thing or like other models if you want.
It's a permissionless Polkadot?
Kind of, yeah. Yeah, and if you want to rename the thread to Parachain, I'm sure. Okay, so fee market design, right? So far this is all consensus layer, and that's all good, but look, we still need to, like consensus nodes still need to be able to know what it is they're actually going to put into these blocks. And I think he wants to have a setup that kind of reasonably preserves decentralization, right? So the main concern here is basically that if you have like 57 execution environments, then even if one of them gets used for over half of all activity, there's still a lot of things that even though consensus layer nodes don't technically need to know about them in order to survive, they might still need to know about them in order to achieve reasonably good profits and collect the transaction fees that people are paying. And so we want to avoid the outcome where the consensus nodes feel forced to just keep on making 79 software updates every week to try to figure out how to collect transaction fees from all these sort of environments, right? Because that would just be terrible for decentralization. So the approach that I came up with for this is this kind of two-stage fee market. And the way that the two-stage fee market works is you have like these two separate fee markets. One of them is universal and on a per block level, and the other is thread specific and on a per transaction level, right? So to just walk through the story left to right, per X thread you have a bunch of users, they send transactions, then transactions get sent to this category of intermediary actors called relayers. Relayers are fully permissionless. There can be a peer-to-peer network of them. Anyone can sign up to be a relayer. But there's technically less need for relayers to be decentralized. And the reason, I mean, I'll explain why. Like they can and should be decentralized, but I'll explain why later. There's no risk of like 51% attacks from relayers or anything like that. Right? So transactions go to relayers. Relayers package transactions up into blocks. Relayers are also the ones that store like thread-specific state. So like consensus level nodes will be stored in the state roots. Relayers will be stored in the state. Relayers will be the ones that actually add a witness to a block, and then blocks with witnesses go to a proposer, and then basically when the user sends a transaction, the transaction of a user has a fee attached, and the fee goes to the relayer. But then when the relayers make a block proposal, they also attach their own fee, and their own fee is a fee that goes to the proposer. So relayers will keep a small chunk for themselves, and look like in equilibrium, most of it will go to the proposer, and the proposer would accept the block proposal that pays them the highest fee. So the idea now, this could be one per block, as I mentioned. There could also be 2 or 4 proposals per block, and you could have a setup where like the proposer can choose. Like, do they accept 164 kilobyte proposal? Do they accept 232 kilobyte proposals? 416 kilobyte proposals? 2 and 1, or anything in between. So relayers hold thread-specific state. Relayers add witnesses. when the proposer is a consensus node, consensus nodes are nearly stateless. Block is verified by other consensus nodes, they're also nearly stateless. Now, so the idea here is that there is this separation of concerns, right? So consensus nodes needs to know nothing about these execution environments or threads, except for one canonical thread that we can kind of standardize that is the thread that runs the key market. So the way the key market works is basically you can just make a signature that basically says, if you can provide a signature, and if you can provide a verbal proof that says this block actually wasn't included, then you get a reward. And that's just all that it is, right? So then the relayers are the ones that are thread specific. There's separate relayers for each thread. They kind of know more about the threads, the local context, and they can collect the transactions and then do what they need to do things like gather up witnesses. Now, the reason why there aren't 51% attack issues here. So let's suppose, for example, that the state of the execution environment everyone uses balloons up to 380 gigabytes. And like basically only one guy ends up being willing to actually hold it. Now let's say that one guy starts censoring, right? So he basically just says, oh, I'm not even going to include blocks that don't satisfy certain criteria. So here is what happens. Basically what happens is that, like, let's suppose that there's some transactions being sent. And let's say all the transactions together have a transaction fee of 20. And out of them, 10 are censored and 10 are things that the relayer wants to censor, 10 are things the relayer doesn't want to censor. So the censoring relayer earns a transaction fee of 10 instead of 20. Okay. Now let's say this starts happening for enough time. Then there becomes an incentive for just anyone else to pop in and start becoming a relayer. And as long as the cost of becoming the fixed cost of storing whatever the state is not so big that it's bigger than this extra difference of 10, then like basically whoever becomes it and becomes a relayer will be able to grab up and just earn a huge profit from the entire set of transactions that have been censored so far. And basically they will be able to set up, rebroadcast a block, and that block will have a higher fee, and the consensus nodes will see, oh, there's a thing from a censoring relayer that's going to be lower fees, there's a thing from a non-censoring relayer that's going to be higher fees, I'll take the second one. So there's basically just a natural economic incentive to, on the proposer side, to accept the things from the relayers that accept more transactions. So so there are sort of economics in favor of doing like yes.
Yeah, so in this case, this also incentivizes the relayers to actually run the transactions to figure out how much they're going to get.
Exactly. So basically, the idea is that it's in terms of like how the key market works. Right, on the relayer side, there probably will be an abstraction system that's like similar to the ones that I talked about, where they'll run transactions for 100,000 gas, see if it hits a breakpoint, see if it pays the fee, blah blah blah. If it does, then they'll package it into a block. And when a relayer creates a block, they have certain, because a block just specifies a very particular free state, they have certainty that if it gets included, it will get included in the state, and they'll execute it exactly this way, and I'll get the money that I deserve. So a relayer, relaying is basically just riskless, right? So as a relayer, if you publish a block where you get a fee of 20 and you pay a fee of 19, then if it gets included, you get 1. If it doesn't get included, you pay 0. Yes.
So what's the differentiator between like a witness and a relayer? What's the witness?
Sorry. So witness in here is the cryptographic term that refers to the things that are like recorded.
Okay. And can a relayer and a proposer both be run on the same machine, like in separate
Yes.
processes?
Yep.
Okay.
I do expect that relayers and proposers will be kind of separate classes of actors, but there might be reasons to like if you are a proposer and if you're running the node, it might make sense to also run a relayer possibly with each other.
Wouldn't it have more economic incentive to do both?
Possibly.
So is the block data identical within like what the relayer is sending on?
Yes, the relayer is, yes, the proposer just includes a block that just contains that one.
If there was right, introduced with that, some way that might circulate back to the relayer, that even a way to stay.
Hey, you say that louder?
Yeah, so if rent was introduced, that circulate back to the relayer.
So by rent, you mean rent as a higher level concept that is created inside of these threads that keep the website down?
Yeah.
Okay, so this is really fun, right? So basically, the threads, they're charged, like the rents that they charge theoretically can go toward anything, right? So it could be burned. It could be used to subsidize optimistic state claims. It could be used to subsidize like snarks or starks proving specific things about the state. It could be just given to proposers. A really fun one is that rent, like the fees from rent could be pumped into a CLR or like some other government gadget that funds development. So that way, like the issuance funding people get what they want without there being any actual political issuance. Yes.
So you were talking about the relayer and there not being really a concern with it being decentralized. So say I'm a relay, but I just want to make sure I understand this. Like, as a relayer, I'm incentivized to essentially like take those transactions, collect the fee, and pay that fixed fee to the block proposer, right? So like I make money, right? Like
yeah.
Keep going. But so what if I'm like, okay, I've made enough, I'm going offline, or let's start censoring. We're not concerned with the fact that like we're not going to penalize it. We're just that
like relayers aren't any kind of a category factor recognized by the protocol. Like they don't have to stake or register or anything. The idea is that there is just enough incentive for backup relayers to just exist, and like
so make it. So you said make it easy.
Yeah, I mean, like it's not going to be like we definitely don't want it to be too difficult to be a relayer. Like, it's yes. So relayers collect transaction fees and they have to pay fees to proposers. And like in an equilibrium, most of it they'll have to give most of the feedback to proposers. They'll probably just get fairly small amount.
What about like the incentive mechanisms for super cuts?
So basically, if you want to just fund longer term availability of like state and historical data.
Yeah.
Are the fees that can be collected by the relayers a function of just individual transactions, or is there something at the spread layer where the spread as a whole is able to provide an extra incentive?
Relayers only get transaction fees. So block proposers. Yeah. So block proposers and so consensus nodes, there's basically three kinds of rewards of penalization. One of them is that there's attesters and shard blocks and they get rewards. Another is that a block proposer just gets a reward for including attestations, possibly a base reward. And the third is that a block proposer has to pay the EIP 5059 fee per byte and per unit test. Then that will realistically just get passed through to a transaction center. So the idea here is to so starting to go through some other questions, right? So one of them is just how do these like short specific rewards happen? And the simplest idea seems to be to just include them in intercrossing data because you only need a few bits to store what the size of rewards is. Cross-thread communication. So this is important because it touches on the question of how do you upgrade these things. So doing cross-thread communication is basically actually about the same as base layer cross-shard communication. Basically, threads can just read state that they receive from other threads by going through the beacon chain and verifying a receipt that goes through the beacon chain and goes through and that goes into other threads, possibly on other shards. If If you want to do cross-thread communication within a shard, it's even easier. You could even just give the reduced function access to a recent state of threads. If you want to move ETH between threads, then what we could do is we could implement an option, like in addition to the deposit, to the withdraw from a validator to a shard, you can have a beacon chain operation that basically does a combined withdraw and deposit that accepts a receipt created inside of a shard, generates a receipt inside of a beacon chain that then can be read by another shard, and transfers ETH from one shard to another shard. Right. So basically, the idea is that now threads, or actually, this should even say contracts. Right. So basically, you can do cross-thread yanking in exactly the same way that you do cross-shard yanking. In the same way that a contract can allow itself to be yanked to another shard, a contract can allow itself to be yanked to any other thread. And so moving contracts between threads is like actually not that difficult and not that bad. So the idea here would basically be that if we have an environment which is like, this is the environment that represents Ethereum, then, or that represents like Ethereum smart contract, or the Ethereum smart contract environment, and we want to upgrade it, then the way that we can upgrade it is we can launch a new thread. The new thread would have new rules, but you could potentially just, like, it would just look like new address space, right? So it will look like new address space, and if you have a contract in the old version, you could just like yank it to the new version. And if your contracts support yanking, then you just yank them over. And if your contracts don't support yanking, then you just keep on living the old version. If anyone wants to interact with it, then they could just like take their coins from the new version, yank it to the old version, do things in the old version, then yank it back to the new version.
Is it, have we, like, you may have to, I guess, if you have like a full frequency, in this case, we're doing a full upgrade to.
So the problem is that you don't want, like, there's two ways to upgrade, right? One of them is like a compulsory upgrade. So you can either give some developers back warranties, or we could even socially agree that like we're allowed to do that for some threads. So that's one option, and that if you do that, then you might as well just change the code of the existing thread. If you want, like the idea with yanking is that if we want to make a new version and allow people to upgrade to the new version on their own terms, then in some ways that's kind of maybe the smoother upgrade path. So the use cases for this that I'm thinking about is like something like Create 2 could be implemented in that way, right? You would only launch off in the new address space if you need it. Or like the Byzantium changes or any of those other changes could be done the same way. Well actually so the idea I had that's on the slide is a bit, it's like an hour out of date. Basically, one idea is that threads can allow whitelisting, that basically say, this thread recognizes that these other threads are legit, and then you can move stuff back to them. But it doesn't need to be the thread that makes the decision, it can be a contract. Like if contracts already have this functionality that says, I allow myself to be yanked to a shard, well, we can have functionality that says, I allow myself to be yanked to this thread. Yeah, basically. Yes. Yeah. The contracts can definitely allow themselves to be yanked into a community. That's the contract's problem. Or possibly the user's problem with the contract has functionality that's good.
Could you elaborate on that, like this is specifically more like?
Sure. So the idea would be that, like, imagine there is like a group of developers, like the Ethereum Standards Committee, and it's the job of the Ethereum Standards Committee to create the execution environment that the bulk of people use to build their smart contracts. So imagine the Ethereum Standards Committee releases environment V1, then they release environment V2, and then environment V2 recognizes that if you're, whoever wrote environment V2 recognizes that environment V1 is legit, right? So they would just add a rule that says, oh, anything on V1 could just be, or anything on V2 could just get yanked back into V1, because we know that there is nothing wrong with it.
Okay, but like in this sense, like maybe there's like a token contract
So basically the idea is that you would just like gain storage between balances, right? It's like the same way that you would do like token balances, where like the status quo is that token balances will live under a single contract, but the E2 approach would be that token balances are contracts, and you know that their balances of one token instead of another token because their address and like create create two if you're running that source. So then you would just be able to yank that into a different shard through the individual.
It'd be like more ideal to not necessarily have the need to yank the storage between the different threads and just to interact with, because if you control the address on the Ethereum 1 thread, and you can control the same address on Ethereum 2.
Yeah, you can do yeah.
So then like,
yeah.
So I was saying like you should be able to like control the same file, so
yeah. Well, the problem is that like thread 1 and thread 2 have different state roots. And it's, I mean, okay, I guess when you, like the problem is that if you want to actually spend the funds, like one thread can only affect things inside of that thread. So you would need to be in the thread to actually save whatever the anti-double spend record is. So like you would actually need to kind of move the state from one to the other. Now the good news is it would be possible to, like, especially within a shard, it would be possible to do cross thread communication within one block. So you could just like yank and then pretty much immediately transfer.
Where it is mutating the state in the other thread?
Yes.
Okay.
Now, if you want to just read without writing, then you definitely would be able to just interpret, like, verify verbal branches associated with one thread and another thread. Right, so if you have like software libraries in one thread, you can totally just call them from one thread.
What if you're addressing, take a step back and define the difference between that thread and shard?
Yeah, so basically, threads are this kind of units of like basically state, whereas shards are ways of kind of categorizing data.
So how is a thread created?
Oh, like basically as simple as anyone can create a thread by publishing the codes of the chain.
Okay, so I can create a thread and just say like this thread is for me and my home.
Oh.
Okay. And so what if I create a shit ton of threads and
you will have to pay a shit ton of fees for that.
What if I don't care? So I'm gonna create a bunch of threads. I'm gonna name this contract around between all of them simultaneously.
Well, but you can't yank simultaneously. You can only yank from one to the other.
Not necessarily simultaneously, but within a very small period of time.
Okay, that's fine. So like, okay, you create 1 million threads, or a few thousand threads, you pay $1 million of fees. Eric Connor's really happy to eat cover. Then you start like taking a contract and just like yanking between them. Okay, fine. Like that's just execution. So what happens?
So what if I'm spending that value within a very short period of time?
Spending what value? The value of the contract?
Yeah, I'm getting it out of it. What if I send it to Binance?
So a contract would only allow itself to be yanked across threads if that contract is sort of contract. Like if the contract agrees that you own the state inside of it.
Yeah, but if I do it so fast, the contract doesn't even know.
No, but like you can't yank, like a contract has to approve.
Okay, so what if it does?
So that's great. You have money, you can send it to finance.
Cash out.
Yeah, and then CC and you're already happy.
Okay, so the answer is I don't give a fuck.
Well, like, yeah, and like if a contract allows itself to be yanked to an untrusted thread, your contract is basically admitting that you own it. Sure.
So it's bad for the security of the contract, but it doesn't affect the security of the system.
Yeah.
Like this question is relevant from a system design point of view.
Sure.
Because it's more, up to the contract, but then, there's no value to this contract because it's, you know what I mean?
Yeah, we're just going to be answered.
Yeah, you use the system where people do that to Ethereum all the time, and they scam and they pay a lot of money.
Yeah.
It's not invalid. Yeah.
when you deploy, when a user level smart contract is something that gets deployed inside of thread.
But thread, it's a state group plus the execution rules.
Yeah, basically, yeah.
And then different rules.
Yep.
So it's like state execution assembly.
Yeah.
And money is burned or created these, so there's like a bound amount that we
Yes.
I guess I'll just make one. You asked a question about smart contract being deployed, right? Let me just make sure. I mean, Thread compute, you can't know where there is no smart contract. So it's really, the Thread has to define that smart contracts exist and then they can be deployed. Really, the thing that you run in Thread are transactions. The transactions might include the contract with Thread.
So the thing that gets put into a block are transactions, and they get run. And if the block, like the block specifies the thread that's used to execute them, and yeah, if it specifies the right thread, then yeah, that thread will execute those transactions.
So there might not be a concept.
There may not be, that's what I was trying to clarify. GTXOs wouldn't have it, or like if you were doing like a sovereign type system, there's no contracts there, it's just verifiable claims with stars.
Or thread that is like nothing.
Yeah.
Yeah. Yeah, there's definitely this kind of deliberate, like huge move for permissionless innovation inside of the thread space. So like you can, as I mentioned, you can do UTXOs in it, you can do a different witness schemes in it, you can implement Crimea inside of it, you can implement Bitcoin elements inside of it. Right?
So I can define what the rules of engagement for my particular thread.
Yeah, I mean, they have to follow the gas on it.
I mean, what do they want to do down to system?
So does a shard pick a particular thread that runs?
No, so a shard is just like a number from 0 to 1,001, right? So a block within a shard picks a particular thread. Yeah, or potentially separate, like a block could contain like any between the two ways.
So like, let's say block 2, I decide I want to use thread 1. Block 3, I decide I want to use thread 2.
Yes.
That's okay.
Yeah, you can switch to thread 1, but then, so let's say block 1 will use the letters for threads to like upload. It's an abstract typing in English. So imagine block 1 has thread A, block 2 has thread B, block 3 has thread A again. The execution of block 3 will be will be based on the pre-states that will use will be the post-state of block 1. So it'll kind of skip over what happened in block 2.
Really threading the execution.
Yeah, right, yes, right.
So does a transaction pick what kind of thread it has to
in theory, if you publish a transaction, it could be put in a block that gets published into any thread. But like in practice, almost any thread would just be a null that does nothing. And so in practice, there's no points in a transaction being included in threads other than the thread that they're meant for.
Okay, so this is assuming that basically there is a concept of like transactions, which is
so the concept of transactions is not a consensus layer.
Right, so that's the thing, because some threads might not even have transactions. So the whole question of like how do the transactions get into the block is like outside the scope of this particular proposal.
It's a real layer.
Yeah.
So how long do these threads exist?
Default is forever.
And how do I become aware of the thread?
There's a list of them on the page.
How is that stored?
So question, sorry, so shards store data, right?
Yes.
So how does the data stored in the shard relate to the threads?
So the data stored in shards, like theoretically, it can be just any random group, right? It's just whatever random group the proposer chooses. In practice, every block has a proposer. The proposer chooses, we'll say for simplicity, thread, and the proposer has an incentive to choose data that's relevant to that thread, so the proposer can collect.
I mean, is there like for me, like the question is like if you're defining this abstract sort of like pure production function,
right?
Is there going to be any way to access
Yeah, okay, so a shard block will have to commit to the state result of the version. So yeah, shard blocks will have that, you have to do this, go for groups, whatever.
Yeah, but we'll just for a thread.
Yes.
Right, but I mean, this is.
Oh, you mean like the roots of all the threads? It's like that is the only state that exists.
Right, so and these are the, like the roots of the threads are the thing that is like in the short storage then?
Yes.
Right, that makes sense.
Yeah, so basically like piggybacking what Philip just said, and Zach, so since you essentially define the rules of the thread, how does the beacon chain verify that what occurred in the thread was correct? Like for instance,
So
OpenAI, how they submit like a state.
Right, so there's two questions there. One of them is like, so this is just a question of saying how do you build blocks and shards are correct?
Right.
So there's two parts to it. The first part is verifying data availability, and you do that with a combination of like, well, first of all, there's like the committee. The committee does the calculation, and so if you trust the committee, there's no problem. If you don't trust the committee, you have data availability proofs and you have proofs of custody. For state execution, you would also have a fraud proof mechanism. So basically, if anyone publishes a cross-link that contains state executes that are incorrect, you can make a fraud proof that points it out, and you can like.
Wait, these threads, they live on the beacon chain or on the shard chain?
No, the code is on the beacon chain. They get executed only by the shard committee, and the shard roots get included into the beacon chain crosslinks. And this isn't specific to what the code is, kind of the way it's all driven.
Yeah.
Yes.
So going through the life cycle of a new thread, basically, since it's permissionless, I create Bitcoin elements. And then people want to use Bitcoin elements, so they start sending transactions with transaction fees to relayers. I'm running a relayer for Ethereum 1.0 on Ethereum 2.0, that environment.
Yeah.
And I don't understand these Bitcoin transactions, but I see that there's fees there.
Yeah.
So then I go out and I start running the relayer for these Bitcoin elements transactions as well,
yes,
because there's fees on them.
Yes.
So I didn't have to update the consensus level code because that was just the new thread. That was a consensus level code. But a new thread always comes with basically new relayer code to understand that.
Yes. And relayer code doesn't go on the beacon chain, it's like a higher level concept, but yeah.
Yeah. Some question I have is, do you see any value in trying to actually allow multiple threads to bundle into the same block by having a meta reduction operation where you have a thread family that agrees that all of their crosslinks have one final reduction into high level? Like for instance, I could imagine coupling together a stateful system, which is fairly expensive to do simple payments together with the UTXO system to get very
I guess my answer would be possibly, but you could probably do that within this framework, like you would just have the virtual threads inside of a thread.
Yeah, I guess I'm just looking at that way you wouldn't have to interleave.
Right.
Yeah.
You know, and the benefit of like actually allowing there to be like 2 to 4 threads per block at consensus level is so that if it turns out that threads aren't a monoculture, then you would still like more of the most popular ones would be able to have like the massively short block times. Yes.
One of the big values is that the upgradability without but I'm not entirely convinced that this precludes having to do upgrades as the intercourse.
Yeah, I mean, like I'm definitely not opposed to the idea of doing hard forks to do like even just especially emergency upgrades to threads at the beginning. Like nothing about the proposal precludes that sort of thing, but it does mean that like if governance of the chain does freeze, then like governance of the kind of experience environment and operates in the experience environment can't still happen. Like there's definitely no requirements that this means that like after phase 2 the chains for themselves forever.
Isn't the goal of all this to come up with a system that has basically indefinite lifetime without hot forks? That is basically the goal, right?
Yeah, that is the goal, like, but I'm just saying it's not something that needs to be reached. Yes.
So, back to the, so, thread is kind of function that takes in a prior state transaction.
A prior state of the block,
Yeah, block and transaction and produces the next state, right? State is sort of short. So, if in one block you use one type of thread, the next block you use a different type of thread, let's say that happens. And you were saying before that in practice what can happen because the rules of the thread probably won't apply across the different ones.
No, so the reason is that the consensus rules basically say that when you process a block that has a thread, your free state is the post state of the most recent block in that shard with the same thread. So the consensus rule stays the over.
So, but what if, like, is there any, like, time limit to this? Like, what if you, like, since an arbitrary number of threads can be, like, scheduled on the same shard in some succession, like, what if you schedule, like, you have, like, thread A, maybe, that runs, like, a block 5, and then the next time it runs, like, a block 10,000? Like, you
That's what the shard, like, that's what the shard state is for, right? So,
right, but I mean, it doesn't live forever, right?
Okay. Like, yeah, I mean, like, we can have, like, a permanent shard state of, like, 32 bytes per thread, you just have to example of
What about thread you're providing a free state, you're providing
Yeah, I just feel like, that would be an opportunity here to introduce something like a TTL for just, these kind of thread states, because it's a very elegant way to ensure that, that nothing is forever. So you kind of have to produce a block that, at least, runs the thread at least once every, like, couple thousand blocks, otherwise it just gets deleted.
Well, you don't want it to be possible to get deleted because you want it to be possible to just have money inside of these environments and feel like it's for them.
I mean, it's kind of an incentive to, like, run the thread provisioning, right? I mean, it's just pressure on the people who have actually produced the blocks.
Yeah, so it would put pressure, but, like, at the cost of reducing the basic safety. And, like,
I'm just trying to avoid the situation where, there is this need to, like, store data indefinitely, because we run into this with E24 and
right. I mean, this is the reason why, like, I'm suggesting that the cost for launching a new environment should be like $1,000. Like, it's the point. Like, the point isn't that everyone has a role. The point is that there's, like, one per group.
Okay.
So can I maintain, like, the state transitions and the value that's being, sent and received within a thread and isolate it there and not rely on any in-chain events if we have assuming we have a healthy community of participants that are.
So basically, the idea, like, if you want to have a thread that's focused on activity that does not have to do with Ether, then can't you just, like, do stuff inside of it and
maintain it within that space?
And then, like, the VT chain itself, like, never needs to.
That's just kind of like a safety net. Yeah. And then, like, we can define our roles of engagement, we're maintaining our environment and community.
Yeah.
And that reduces overhead. It's like.
Yeah, you can totally do such things. Yes.
What's the reason for, like, capping how many threads block puts your life essentially execute on? Because it seems like it's all on one shard and they
right, like, potentially you could allow, like, 20 of them to execute.
Arbitrary.
Okay, so actually, so in an earlier version of this proposal, I had all of the shard updates, all of the updates to states be synced to the beacon chain. And if you have too many threads, then that will be just too much overhead. In the proposal where they stay inside of shards, maybe that's not necessary. Maybe you could just like dump all of it.
Where they just are costing.
Where it's just shards data and eliminated, it just gets crosswise.
What if you like incentivize people to maintain activity within that particular thread?
Incentivize people to maintain activity.
Yeah, rather than withdrawing that value, which then becomes a cumbersome responsibility for the chain.
Mm-hmm. Yeah, you could. And the beacon chain is going to have high transaction fees, right? So there's an incentive to not look there. And you could even have a minimum balance of could also charge rent on a beacon chain, but that might be a bit of more complexity.
Can you walk me through like the user experience? I'm a dude and I want to set up a thread.
Sure. Basically, you would so step one. Let's say you anywhere except the beginning of the life cycle, you would have your ETH. Like you would start off having it in shard because and in some thread because that's for 1 minute, so like 7 more. Right. So you have your ETH in the thread. Then you would use the withdrawal mechanism of that thread. So now you basically created a new beacon chain validator slot. And that beacon chain validator slot has an ETH balance. Step 3, you would make a beacon chain transaction. And that this would be a special beacon chain transaction type. Actually, forget it. We call them transactions or operations, like whatever that word is.
Just call it operation.
Okay, it's an operation. You make this will be a new kind of operation that would it will be called like a new thread, and it would include the code. And it will be pretty big, like the code could be up to 64 kilobytes or whatever. And this would have a fee, and you would be over 200 ETH. And you would just, when the operation gets completed, the fee will get deducted from your account, and then the beacon chain contract will just get automatically added onto the beacon chain stage. And there it is, it's created. And then you can pretty much, like as immediately or with a tiny delay, as soon as shard chains become aware of that beacon chain blocking,
So that's sort of the smart contract that's then deployed on the beacon chain itself. Okay, so what do you do and then that becomes immutable and you can't remove it ever. So then we're in the same issue with stateflow that we're in now.
No, not to the same extent because the beacon chains are insanely expensive. Like the goal is to just target a growth rate of 10 megabytes a year or something. And if we want, we could make them have a finite lifetime of like 20 years or something. Yeah.
Would you pay according to the time span that you define? Like I want this thread to exist for 5 years, here's my fluctuating cost.
Yeah, you can do that.
So one more dumb question. Is there a concept of Ether on the beacon chain?
Yes.
But that concept is separate from any sort of like Ether on any thread in any shard?
Yes.
Okay. So it's like
yeah, it's like special ETH. Well, it's technically any ETH you have on a shard is like a voucher for ETH. But like ETH is like the underlying ETH. ETH on a shard is a voucher.
Yeah, that makes sense. Okay.
You're talking about how earlier slide is next to two levels of the fee market, and that only one is catered to the closer. Is the other fee like allocated in a different way, or is it like if they're all flavors of fee? It's just like
The simplest thing to do is the fees can technically be whatever people agree, but like we don't want to make life hard for consensus nodes, so realistically consensus nodes would be just accepting ETH. And relayers could just theoretically accept fees in whatever they want, but like, the simpler thing is to just take ETH, yeah.
So the beacon chain, you're saying that's where you're saying.
Sorry, so actually no vouchers.
Okay.
But no, so consensus nodes, like there would be one specific fee market environments that they would have, and they would have distributed vouchers in that environment.
It's like really stupid. I want to do my own ICO. Okay. I'm going to deploy a thread for my particular ICO.
Why not just like run this?
What's that?
Why not just run the thing as a contract thing?
Because I want to have a higher degree of logic that will allow me to define who I want to participate with.
You can probably do that as a contract.
And like both of these threads.
Yeah, it's like basically the time you want to create a new thread is like roughly the time you would want to create either a new programming language or like
Right, but I want to launch like or something. UTXO based chain. Okay. Put that in the threads.
Yeah, you want to make a UTXO thread, you make a thread. But that's more like a programming language. Yes.
transaction, you specify which thread you want to run on.
Transactions are not a consensus layer concept, so there's no consensus layer in a policing of that, but realistically, like individual threads would probably you're creating a thread, you're creating a thread, and really those can be whether it's a framework, you can do whatever you want. But by creating the rules of the relay thread, you kind of are like creating the incentives that will lead to what people are doing.
So if I have a thread, within my thread, I define some crazy ass logic that doesn't really, isn't really recognized outside of that thread within the key chain. Like, would I just keep my thread open in perpetuity to provide that logic that's required? Because as soon as it meets that system and that process.
What kind of logic?
Like let's say I want to do like UTXO and I don't care about this or I want to adjust my keys or I want to, like whatever, right? Okay, so then that would incentivize you to maintain that thread being like open because the value would be useless outside of that particular environment.
Yeah, and like if the value is objects that are generated in the context of that thread, then it's pretty much. If the value is vouchers, then like you can always withdraw vouchers. But like you do need to say you withdraw vouchers.
I have a new thread and not very incentive for feeding
yeah, like basically if you imagine if there's a thread that has say 1% of the usage of the most popular threads, then you'll just have to wait 100 blocks until there's enough usage for that to keep the others, and then they'll get included in that blocks. Now, if the other thing I forgot to mention is that you should be able to set it up so that threads are specific. Threads don't have to expose, like, open themselves up to the entire range of shards. So threads could voluntarily restrict themselves to a range of shards. And the benefit that this has, one is that it reduces stable load, and the other is that by concentrating yourself in a few shards, you concentrate your users more. And so you might be able to be very frequently dominant in a small array of shards. Like it's probably the right thing. Restricting yourself to a few shards is probably like the right choice for the individual.
Like the primary application is essentially like a DEX, right?
Well, the primary application for this is anything you want to do on Ethereum. DEX.
But I mean, like solving UX issues, like that's probably like main space, right?
What do you mean?
Well, like, okay, so DEXs currently have to deal with very, I guess, pick a shard and deal and either get users there, deal with
Oh, right. So like, Uniswap would live on one particular shard, and then if you want to use Uniswap, you would basically like step one, yank your points over to the Uniswap shard. Step two, treat like Uniswap. Step three,
yeah. So you guys sign there for like, right?
It doesn't need to be like MetaMask can just like send the two things as one transaction, or it can just send them at the same time.
Sure. Okay. Yeah, but okay. So now with the threads, could you not in theory likely exchange on a thread?
We could, yeah. But if it's a decentralized exchange, you realistically want to run it as a contract system inside of the thread that most other people are on.
Okay.
Like I think the intention is that for a thread, it's like the analogy of a thread that it's like a programming language rather than being like an application.
So the code that's stored in the beacon chain, that's impossible, right?
That's what?
Is that would that be impossible?
Yes.
Okay. And like, is there like some sort of validation to make sure that, hey, this like will actually work? Or is it like a free for all, and if you just want to dump like 100K worth of ETH, worth of like ETH to like to activate the thread, like there's you can just make a mistake and it's like there goes all your ETH. Is that the idea? Like
if you dump that code lost your ETH. Like you definitely want to like formally verify or whatever before you deposit.
Right.
It's like the same thing as like what you do with your multi-sig wallet before we put 100K into it.
Sure, yeah.
Yeah, and thread code is definitely a high stakes thing. And people be careful of it.
Yeah.
It looks like there's a really high chance for people to just like be very confused with this threads concept because it's like given all the questions that have come up already, where it's really like the notion of a thread being something that is like going to come up like again and again. Yeah. People will be confused by this for a long time.
Yeah. Oh yeah.
Yeah.
I mean, people are going to be confused about cross charts, calls, regardless, right? People are figuring out MetaMask still. So.
A particular thread on more than one shard. Yes. So the statehood of the thread would be specific to the shard. Yes. Right.
General thoughts or ideas on the exchange shards to actually smart contracts.
What do you mean abstraction shards?
People just don't like developing or taking this wallet, probably building shards, just that space kind of abstract.
Yeah, I mean, like, you definitely don't want wallets to like require people to think about shards, and this is one of the reasons why I think fast contract communication is really important. Which is like, you want to just have your state forever, and if you want to do things, you just like move it over to the thing, move it back. But there's 2024 of them.
But is there any additional logic? How do we use some of those questions?
That's like, it's intended to be kind of homogeneous, right? So basically, every shard has this has its current community and the current community, and will kind of continuously reshuffle over the course of a few hours. So if you're a validator node, you would just like go to whichever resource you're pushing. You would go to the peer-to-peer network associated with whichever shard you're assigned to, and then you would just switch over and pull to the shard. If you are a relayer, then you would just stick on whichever shard you want to be a relayer on.
Zach, can you say that louder?
I said relayers probably don't care because it wasn't just passive actors.
But relayers would definitely want to specialize in like one or more threads and one or more shards and just like take that responsibility. Otherwise, they don't move around.
So what's the organization like verify it's
like a market, like it's not enough people care about laundry within the environment. Not necessarily, because like realistically, relayers would want to just like specialize in one environment. So it's not a good purpose.
I think a little bit talk about other benefits that they have first phase.
Yeah, so I think like the big benefits that I talked about, one of them is just the 2x efficiency gains, which is basically that you don't, instead of having persistent committees and cross-node committees, you just have like one kind of committee. It also means that we don't have to worry about the complexity of consensus layer passing using algorithms. Another big benefit is that you can basically, like, we don't need to specify like what the big state looks like and how the big state like actually gets normalized, and so you can experiment with different things in algorithms. I definitely strongly agree with that. Another statement I want to kind of make strongly is that when, like, if you're in 2.0 phase 2 launches, like if it launches and we take this approach, then I would expect there to be, really want there to be like at least one major, like, high quality thread with all of the tooling around it, so that from a developer point of view, like, they don't theoretically need to understand all of it, they just see here's transactions, here's how you launch code.
So the model is very general, but that doesn't mean that like everyone has to provide that totally general model. It's like somehow also trying to, you don't necessarily have to generalize every implementation to the point where it can deal with any thread in any way. Like exactly, you can totally specialize. Like these questions about like transaction handling and everything, these things transaction handling even in E1 now is an implementation specific thing. Like there are implementations that do certain things better and other things better, and it's the same for this, except there can be actually like a diversification in terms of like how which thread you're handling the transaction for, and you don't have to like support everything. Yeah. Yeah, so it's just to give some context because this is so general, like it's
so yeah, so that we can just like deploy experimental logic and the process of actually like pushing something out is fairly easy.
Yes.
Yeah, nice. We have like an SDK or some shit.
It's like whatever I use most of it is like exceptions, right? Like all of the ideas transactions. It's also specific. So you can build just like security infrastructure, right?
This is like the spread environment removes probably the need for hard forks for anything that doesn't involve a consensus upgrade.
Yeah, again, the long-term goal here is yes, like if this does basically mean that we could eventually just stop doing protocol hard forks and we still have like ongoing permanent innovation environments. And it doesn't mean that we have to commit to doing that from one. Like I think being willing to kind of do DAO forks for the first year or 2 years might be a good thing. But like eventually, this is totally kind of friendly toward the consensus governance staying in governance happening on this like threat standardization.
Okay, cool. Thanks for coming. That was great. Okay. So yeah, thanks everybody for coming out. I think I think the ETH implementation teams and we're getting like a little bit closer. I think it's like good momentum. Thank you.
Hey, one more thing. Can you mention maybe like a network breakout group, possibly? Like
If you all want to break out.
We just need to agree on like the time. I guess everyone kind of needs a break now. And we kind of pull it out, like the next time where we meet.
Yeah. What are the future ETH?
We have this one that we were talking about earlier, is Interop.